Okay, a very warm welcome everyone. So today on lesson number 5, we'll continue with the concepts of artificial neural network. Up till now, we have conducted 4 sessions where we have started working on artificial neural networks from the very first concept. The first concept which we addressed was a perceptron, followed by we have implemented a perceptron with a movie observations dataset. Along with, we have implemented a multi-layer perceptron using MLP classifier on our first session. We have also visualized the neural network using Visualize NN library, which we have downloaded from Git. Now, post that, we have proceed towards sigmoid activation functions, where we got to know how neural networks learn, how they activate neurons on the basis of dot product of inputs, weights, and the bias. So now we all got to know that deep learning is a concept wherein we try to adjust the weights, and using these adjusted weights, we try to identify the best possible combination of weights, and learning these weights by the neural network is known as deep learning. So we can take up any problem, we can uh, identify the features from that data, we can represent that features as layers. Let's say we can take it as an input layer, and within that input layer, for every individual state, for a specific case, or for every specific row, or for every specific example, we can represent all the columns or all the features on a neuron, and then we can apply an activation function on that so as to activate the hidden layers, and followed by activation of your output layers. So that was the first thing which we did with sigmoid functions. Post that, we processed restricted Boltzmann machines. Over restricted Boltzmann machines, we got to know that when we don't have a data set which is labeled, which means if we are not having a dependent variable in the data and we don't know what to calculate, then what generally we do, we try to identify the hidden patterns in the data. And what kind of hidden patterns we can identify? These hidden patterns could be the similarity, the principal components which may be responsible for the outcome for a new state or for a new example. So we implemented restricted Boltzmann machines, and we have implemented a simple implementation of restricted Boltzmann machines also. So as of now, you all understand the basics of what a neural network is, how neural network activations work, what all visible layers, input layers, and hidden layers are. And you also understand that how we can define our neural networks. So neural networks is all about learning the weights and all. So once you know the right combination of weights, you take an input, apply the activation function, and you activate the neurons. Now, what we have to do is, when we face the real-time challenges, there are a lot of other algorithms available, or there are various frameworks available, in fact, which offers a lot of algorithms for artificial neural network. So the algorithms which we use, like RBM, the algorithms of perceptron implementations, whatever we have done till now, we have frameworks available. There are very common frameworks like TensorFlow, PyTorch. These are the most common frameworks which are generally used in the industry. So today we are going to have an introduction into the frameworks which we can make use of in order to implement artificial neural networks. These are built up codes. They are already built up by an organization or a community. In case, since Python is open source, what you can do is you can explore the code among how these TensorFlow and PyTorch are implemented and how they implement each combination of algorithms and the parameters. You can explore everything. So we'll make use of Keras today. Keras is based on TensorFlow, and we will be using Keras library. Keras is just like a library which offers you a lot of neural network algorithms. So we will understand that how we can create the input layers, how we can create a densely created neural network, how we specify our information into the functions specified by Keras, and then we can take the observational data sets and perform certain analysis like hand digit recognition. And there are so many examples though. So we'll get started with the first one. Now, the major objective of today's discussion is to understand the concepts of auto-encoding. And we will be implementing these auto-encoders using the Keras framework. So before I start, I would like to give a quick look to all of you what autoencoder is. Let's have a look. So we'll quickly go here, define autoencoder. Okay. So you can see that. Let's reach out to the article on Wikipedia. So here you all can quickly observe the official definition of what an autoencoder is. We will be exploring these autoencoders today. So what is an autoencoder? So as you can see, the official definition says it's a type of artificial neural network which is used to learn efficient data codings in an unsupervised manner. So what is the meaning of this? This means you are going to understand the states. Encoding the data means you have to identify. Efficient data coding means you have to identify the responsible features which can help you activate the outcome or identify the outcome. Okay. So the aim of an autoencoder is to learn the representation. You can say whatever value is available in the input layer, he will try to identify all the features which are available on the input layer. And finally, the objective of autoencoding is typically dimensionality reduction. What do you understand by dimensionality reduction? So dimensionality reduction in machine learning is a concept wherein we reduce the dimensions from the input data. So suppose you are given a case, let's say you have to make a movie recommendation system. Within that movie recommendation system, we have got, let's say 1000 features in the data. 1000 features means 1000 columns. Okay. Uh, so once we try identifying the pre-processing of the information and normalization of the information and calculation of correlations among the features and the identification of principal components. So once we have identified the principal components which can actually help us predict the outcome or reach the outcome, we would be interested to carry those dimensions only for our analysis. And the dimensions which are not useful in prediction of output, we can remove or we can reduce those dimensions out of the input data, which we will be providing to the algorithm in order to learn the states and in order to predict the outcome. So this is dimensionality reduction for you, wherein from a given input data set, you're going to identify the columns or the features which are highly responsible in prediction of the output, and the factors which are not responsible, you are going to reduce them. So by training the network to ignore the signal noise, here is an example which is given over here. So we'll be working on this concept today, that how we perform principal component analysis and we perform dimensionality reduction on unsupervised data sets where we don't have the labeled or structured information available. So in supervised learning, once we have been learning supervised learning, you all got to know that we do have correlation analysis. And in the correlations, we were used to plot a graph and we used to check the influence of independent variable on the dependent variables or the other independent variables. So that was identification of correlations. So correlations is a form of identifying the influence. And similarly, once we got to know that, let's say there is a specific number of columns available which are not influencing the outcome, so we can reduce those dimensions out of the input data, and we can take only those features which are highly responsible in prediction of the output. Then we can train our model in order to learn the weights and predict the outcome or identify the similarity and like that stuff. Okay. So what is an autoencoder? Autoencoder is a neural network which is generally used for dimensionality reduction. Okay. This is one application type. Second, now here you can see that along with the reduction side, a reconstruction side is learned where the autoencoder tries to generate from the reduced encoding a representation as close as possible to its original input. Okay, so this is also very important. Now, what an autoencoder is? Given a data, you have to encodify the dimensions. So let me just quickly draw that for you here, so as to give you a quick understanding. So uh, let's say we have got some input variables here. Okay, and I'm going to say, let's say within this, we have 1000 columns. Okay. We have 1000 columns, and generally these columns are also known as features. Okay. Now what we can do is we can make a neural network, and using this neural network, the next stage would be a stage of hidden layers. And within this hidden layers, what we can do is we can perform the encoding process and we can reduce the dimensions. So let's say in our current case, whatever the data set is, we have performed dimensionality reduction, or you can also call this process as encoding. Okay, I just type that here, encoding process. So once you're trying to encode here, what you will get in the output, it would be possible you are left with only, let's say, 70 columns, which were responsible in order to predict the outcome, let's say. So this part is known as reduction of the data. This is known as dimensionality reduction. Initially, in the input data, we got 1000 dimensions, but once we have applied the neural network, once we have applied the encoding algorithm, we have reached out to, let's say, 70 dimensions in the hidden layer. Okay. So here is an example of a neural network here for you. So let's say we have sent a state here and we got approximately 70 reduced. Now what next? So next statement says, now here the encoder tries to regenerate using the reduced encoding a representation as close as possible to the original input. So this is the decoding process. Okay. Now after this, you will be having a decoding process, and again you will try to generate the appropriate input again out of that. Okay, using the reduced parameters. Okay, so this means you will be using 70 parameters as the input parameters, and you will be generating an equivalent input with reduced dimensions. Okay, you're going to get the equivalent input with reduced dimensions. Now what is the meaning of equivalent input with reduced dimensions? This means the output will definitely be less than 1000 dimensions. Okay, it's going to be less than 1000 dimensions, but it will be equivalent to the input. Okay, which means you can recognize it. Let's say you have given an input, your output will be able to recognize what was the input given. It may be possible it won't be exact the same dimensions, but we will be able to generate the output data in such a format that we will be able to relate that with the input provided. Okay, which means we can match with the input. Now what is the utility of this auto-encoding? So this process, is, you can see, this is actually a compression process. Okay, what is this? It's a compression process. So let's say if you have an image of a lot of times you would have seen, let's say once you upload a image on Facebook. Okay, so what Facebook does, it takes that image, it tries to read the dimensions. It may be possible the image is of 1200 cross 720 size on Facebook, let's say by default. You have got an image of 1200 pixel cross 600 pixel. Okay, so that's the input image. It could be possible the image is of, let's say, 2 MB. Okay, once you uploaded that big image, it was of 2 MB size. Now what Facebook can do, it can apply auto encoding. It can identify the important features of the image. After identifying the important features of the image, it will perform encoding. After application of encoding, he will identify the reduced number of dimensions, which can actually help reconstruct or regenerate the original image. Then he is going to decode the operation, and after decoding, again he is going to get an image of this pixels, let's say 1200 cross 600, but with a lower size, and this would be, let's say, 10 KB. Okay, earlier it used to be 2 MB size, but now it is going to be of, let's say, only 10 KB size. So this compression is also an application of auto encoding, which is generally implemented using artificial neural network. Earlier what used to happen, आपने बहुत बार ऐसा देखा होगा, आज की डेट में बहुत सारे ऐसे सॉफ्टवेयर्स हैं कि आपने मान लीजिए एक वीडियो बनाया, ठीक है, आई विल गिव यू एन एग्जांपल आल्सो. देयर इज अ सॉफ्टवेयर नोन एज हैंड ब्रेक. I generally use that software a lot. Name of the software is Handbrake. So मान लीजिए आपने कोई MP4 वीडियो रिकॉर्ड किया, ठीक है, आपका MP4 वीडियो जीबीज में है, मान लीजिए आपने आफ्टर इफेक्ट्स यूज किया सॉफ्टवेयर और कोई एक बहुत बेहतरीन वीडियो आपने एनिमेशन वीडियो बनाया फॉर एग्जांपल, and you got a 2 GB or a 1 GB kind of file. Now what you can do is you can make use of Handbrake. You can decompress it. You can compress it, sorry. Once you compress it, it may be possible that 1 GB video would become a video of approximately 5 MB or something. Okay. So there is a lot of storage space which you have optimized. But once you play that audio or once you play that video, you won't find any big difference in the quality of the video. Okay. So that means after compression, what happens is only those features which are actually responsible in generation of the video will only be accounted, and all other features which are used in the video format or in the video compression, it will be removed out. So that is somewhat a process of autoencoder, which we are going to understand today. So guys, just a quick question with all of you. Are you guys able to understand what an autoencoder is? So it's a type of artificial neural network. What it does, it tries to perform efficient data codings. That means it will try to identify the appropriate features which are actually responsible for prediction of the output or for activating the neurons, okay, in an unsupervised manner. So the aim is dimensionality reduction, and the process is it tries to encode the data initially, and then it will decode the data, and it will offer you a compressed result. And it's not necessary that it will be only used for compressions only. It is used for various applications in neural networks, but dimensionality reduction is one of the most common examples or one of the most common applications of autoencoding, followed by the data compression. So if you're clear with this, please let me know on chat if you guys are clear till here.
Hello, sir.
Great.
Hello. Hello.
Okay, so you all are clear with compression as of now. Let's proceed next. So it says several variants exist to the basic model with the aim of forcing the learned representations of the input to assume useful properties. There are examples of regularized autoencoders, which means we can perform sparse autoencoding, we can perform denoising based autoencoding. So denoising is an example wherein, let's say, you have got a keyword or you have got some text which is badly written over a background, and it's very difficult to separate the background with the actual text written. So we can make use of autoencoding. We can remove the background out of it, and we can actually extract only those features which are of the handwritten image or something like that. Okay. So in denoising, there is an example, there is a use of autoencoders. Along with one of the most favorite or one of the most common autoencoders are variational autoencoders. Okay. And these have their recent applications as generative models. And we'll come to that point that how we can make use of variational encoders and what would be the applications of variational encoders. So one of the common application of variational encoders is face recognition, and there are various other. So we'll work out on that, how these things work. So today the objective is to implement a simple encoding network so that you guys will be able to understand how encoders are implemented. Along with uh, the second objective is to get started with a framework which can make our life easy. We don't need to code each and every algorithm every day. It's better you can go out and read the concept behind how that code is implemented for every individual algorithm, because what is the difference between the simple neural network and what all algorithms will be exploring is only the equations and the activation functions which are being used. Okay. Otherwise, the concept will be similarly implemented as we implemented the perceptrons as well as the RBMs. So let's proceed further and we'll use how we will be using Keras today. But before that, you can see that autoencoder is a very common, it's a very useful concept when it comes to the following use cases and applications. Now here you can make use of dimensionality reduction, information retrieval, outlier detection, image processing, drug discovery, tumor analysis, population synthesis, and there are various other options available with which we can make use of autoencoders, and we can apply autoencoding technology in these areas. Okay, now let's see. So let's proceed further. Somebody wants to annotate anything? Hello, sir. I have a question. Yes, please, Mr. Subham Ghosh. Go for your question.
Hello, sir. Hello. 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 Hello.
Okay, by the time you write your question, we'll just proceed further. So guys, let's quickly understand the basic architecture, what autoencoder is. So you already got the introduction that it is a neural network, okay, and it's a neural network that learns to copy its input to its output, which means you're going to receive an input, he'll try to learn the inputs, he'll reduce the dimensions, and he's going to reconstruct the input again. So what would be the benefit? The dimensionality reduction, the compression, these will be the first benefits. Okay. Post that, in case if we are able to successfully learn the inputs, what we can do is we can use those inputs and we can apply it on a noisy data, and we can extract the information from the noisy data also. Okay. Post that, there are a lot of other options which we can make use of autoencoding networks. So dimensionality reduction, feature learning, these are some of the most important implementations or applications of autoencoders, which we will be implementing. Followed by, what is the basic architecture? Let's have a look. Okay. So when it comes to the basic architecture, you guys can quickly see. Let me just open the image in a new tab, copy image address, and I'll just open that here. Okay, here. So as you all can see, I've got the basic architecture of the neural network available, so which I've already drawn for you. So you have an input layer. There could be a number of layers in the neural network, but let's take a very simple example. Consider you will be having one visible layer, one hidden layer, and one output layer. Okay. So output is going to be a copy of the input layer, which means we are going to receive an input. This input could be an image. Consider an image. Okay. So let's say we have given an image to the input layer. Out of that image, we will try to read the features from the image, and we are going to reduce the dimensions. So the dimensionally reduced encoding part will be done here from the encoder, and in the hidden layers, you will be having an encoded data, which is here. Okay. Then what will be done? You will be using this encoded data in order to reconstruct the output. And this process will be known as the decoding function. Once you decode the data, you're going to get the input image regenerated, and the visible difference would be the compressed data. So there will be differences in the image. The input image could look a high quality image, and the output image could look a little low quality image. But the overall objective to accomplish here is the compression and the dimensionality reduction, so that in the cases where a lot of images are considered, okay, let's say a social network where every instance of time, millions of videos and millions of images are being posted. So the server of Facebook will become too heavy in case if each video of 2 GB and each image of various MB is uploaded there. So what they do, instead of just using the common decompression technique like a regular compressing of the data, what they do is they apply neural networks, they identify the appropriate features from the image, and then they try to reduce the size of the image. Okay, so that's why you can see there is no variable difference in the quality of the data or quality of the image on Facebook when you upload, but the size is heavily reduced. Okay, so this is one application. So I hope you all are aware with Instagram, and there are so many options there. So you can see the example. You can take a 2 MB image, you can upload it on Instagram, and again, if you download the same image from Instagram, it will be of a very reduced size. Okay, you can do that demonstration at home. So how do they do that? Because every image is different. So they feed those images to the neural network, and they have trained a model. Using that model, they auto-generate, they reconstruct the image, and then they use the reconstructed image. They create a new reconstructed image at the server, and then they link that image with your account, whatever it is. So let's see how we are going to make use of the concept. I hope this is clear to everyone that what is an autoencoder. An autoencoder is a neural network where you have three layers: an input layer, a hidden layer, and an output layer. Not just three layers, it could be n number of layers, but three major layers, let's say. So it could be one input layer, n number of hidden layers could be there, and finally the output layer. What would be the difference? You're going to get an input, consider an image, you're going to perform dimensionality reduction on it. Using the reduced dimensions, you're going to reconstruct the input, and once you got the input reconstructed, you can find a variable difference in the size of the data, but there won't be much difference in the quality of the image which would be generated. Okay, that's the overall objective. But the simple encoder which we will be implementing today may not be able to give you that high quality image, so there would be visible differences among the compressed image and the original image. But as soon as we proceed towards variational encoders, you will be able to identify how to maintain the quality with the appropriate features while reducing the size and the dimension at the same time. Now let me just go here. So there's a question. Suppose I have a video 1 GB, but finally the output of the video will be same because size is changing. So I didn't get the question. Suppose I have a video of 1 GB, that's fine. But finally the output of the video will be same because size is changing. Yeah, definitely. The size is changing. That means when you created a video, let's say you have created an MPEG 3 version, that is MP3 version. Okay. So once you have created an MP3 or let's say an MP4 version of a video 1 GB, so there could be possible that there would be a lot of features for preserving the data, preserving the metadata, and there could be a lot of other information available in that input data of 1 GB. So what we can do is we can quickly take that input data video, we can create a matrix, we can quickly display it in form of numbers, then we can feed those numbers to a neural network. And now what neural network will do, it will try to identify those columns and those features which are actually able to activate the hidden layer. Okay, activation of the hidden layer means we are trying to reduce those components which are not activating the hidden layers or which are not responsible in construction of that data, whatever the video data is. Okay, so eventually what happens, as soon as the columns gets reduced, your size will get reduced. But for the video, whatever is responsible, let's say whatever columns are responsible to ensure the quality of the data, that will be retained and they will be sent to the output. And finally, once you get the video, you will see there will be no big difference with respect to size of the image, size as in the pixel size. I'm not talking about the data, the file size. I'm talking about the display size. So display size will be same, but the file size will be reduced a lot because a lot of information has been reduced out of it. Okay, and I'm going to show you an example today itself in the while we will be coding. So you will identify the variable differences, and as soon as we proceed towards the variational autoencoders, you will be able to maintain the appropriate quality also. Okay. So I hope the concept is clear to everyone that what is an autoencoder. It's a neural network which helps you dimensionally, which helps you offer dimensionality reduction. And once you have reduced the dimensions, you can reconstruct the output with those dimensions so as to have a reduced size with the same input, with the output as equivalent to the input provided. Okay. Now let's see, let's go here. So how it works? So it works on a very simple logic. Initially what you're going to do, it also works on the same logic here. So in the simplest case, okay, given one hidden layer, the encoder stage of an autoencoder takes the input. Okay, let's say we are going to receive an input, and let's say the input is X. We are going to map this input to a hidden layer. And what is the activation function to map it to hidden layer? It is similar to your neural network activation function, the sigmoid activation, which we generally use. So you can see that we got that we are going to take the input matrix, we are going to multiply that with weights, we are going to add the bias, and finally we are going to perform a sigmoid function, which means 1 divided by 1 plus exponential to the power of minus weight x plus b, the product of weight x plus b. So once we are going to use this activation function, we are going to get the hidden layer out. Okay. And now using this hidden layer, we are again going to reconstruct the output. Okay. So you can see that this image H is usually referred to as code, latent variables or latent representations. Sigma is the element-wise activation function such as sigmoid function or a rectified linear unit. So we will be using rectified linear unit and sigmoid functions both today. Let me tell you a very big difference between both of them. So here's a quick catch which you all should know when you will be implementing an autoencoder. So when you try to encode an image from input layer to a hidden layer, what activation function you will be using? You should always use rectified linear unit. Okay. There are a lot of advantages of rectified linear unit over sigmoid function when it comes to encoding, when it comes to the operations of encoder. What sigmoid function would be, what rectified linear unit would be capable of is, it will be able to represent the data in a positive integer format. Let's say generally it is said you can represent it into any numbers up above from 1 to any number you can represent using rectified linear unit. Okay, so that is the best part. So once it comes to learning a lot of features, okay, when you have to come a lot of features, when you have to learn a lot of features from the image, and when you try to encode it, using rectified linear unit is the best option. Sigmoid function won't be able to represent a lot of features between a range of 0 to 1. Hence, what we do in real-time autoencoding cases, what is done, we make use of rectified linear unit activation function, and we represent the features for a value from 1 to above, to any number of value you can represent. So there is no limit. You can represent the features from 1 to infinity, or let's say from 0 to infinity. But in sigmoid function, you can only represent the features between 0 to 1. So here is a very big difference. So when you will be encoding, you always have to use rectified linear units. And when you will be decoding, then again it's fine. You can make use of sigmoid, because when you will be decoding, you just need to represent that whether the neuron is going to be activated for that particular input or not. Okay. Now here, so in the context of artificial neural networks, the rectifier is an activation function defined as, this is the equation of rectifier function, maximum of 0 comma x. Okay, so whatever value you're going to get in x, okay, and what would be x? This x could be your input, whatever the input we have taken from the image. We're going to take the max value out of it, and we are going to represent that value here in x. So let's say in case if you have an image with 784 features, so you can represent from 1 to 784 using rectified linear unit. And when you are going to apply that rectified linear unit function, you are going to hold the same value, whatever is available in the feature. But if you will be using sigmoid function, you have to represent that 784 value into between 0 to 1. So sometimes it becomes very difficult to distinguish between different features. Okay, because I've already told you in the first session, when you will be taking images, there would be a lot of states possible. Because suppose if you have an image of size, let's say 1200 into 600, 1200 into 600, okay? So then how many features would you be having on your first state? You are actually going to have a lot of features, okay? So here is something which you can make use of. 1200 into 600. So you will be having 7,20,000 features on your input state. Representing 7,20,000 input features on one layer with sigmoid function is really very difficult. Hence, what is done? Rectified linear units are used, and the formula is very easy for rectified linear unit. That is maximum out of 0 or whatever the x feature is. I hope this is clear to everyone. Okay, now let's see. So I hope a lot of theory is done. Let us just quickly proceed to how we are going to implement that. So the activation functions are pretty similar. Then you will be having a feed forward neural network. You will take the information, proceed it to the output. Okay. Then we'll understand about sparse autoencoders. There are various autoencoders available: sparse autoencoders, denoising autoencoders, contractive autoencoders, and finally the variational autoencoder. Okay, so variational autoencoder are quite important, and they are considered important in deep learning. So we'll reach out to that concept soon. But initially, let us just implement what an autoencoder is. Okay, is that clear to everyone? Please let me know on chat if you guys are clear with the concept. And just to confirm, my voice is audible to everyone properly. Okay, fine. So now what next we have? So I would like to share some very nice resources with you, just to give you a quick idea about what we guys are going to do today. So let's say over the auto encoding part, I'll take you to Devanshu Shukla's card, and I need to give you something pretty nice. I have got, yeah, I guess this visualizing neural networks. I would like to give you, this is the resource which I've shared on the first session also. I hope I have shared that. Otherwise, if I forgot somehow, let me just share that now with all of you on chat. I'm forwarding this link. You all can open that on your machines just to have a quick look. And I would really recommend to go through with the article to understand visual neural networks. So it's considered as a grand tour for the project which we will be taking up. Okay. So for as far as the explanations are concerned, I would recommend you all to go through and read the tour. It's very nice. You'll get to know about a lot of algorithms and whatever you are learning, how you will be implementing that with the current case. But I'll give you time to go to the article and dedicate some time and understand the concepts behind all these technologies. But in the session today, I'll just quickly describe the major objective. So here is the major objective which we'll be implementing somehow today. So this is the objective of a complete project, how it has to be done. But we will be doing only one part. Okay, we are doing the first part out of it. So what first part we'll be doing out of it? We'll be doing something like this. So this is the complete project, but we will be doing something like this. We'll be implementing this part. Okay. And post implementation of this part, I can also show you this part also. Let's say. Okay. So consider this part as the encoding part and this as the decoding part for one layer. Okay. Let's say we will be having, we can have n number of layers because we'll be using Keras today. So that won't be a problem. So you will be doing something like this. So first part which we will be implementing here would be encoding. Okay. Now what would be known as encoding the data? You're going to get a clear image Okay, let's say you have got 7 out of here. You're going to read the features of a value, let's say 7, or we'll be reading the values from 0 to 9, all the values we will be reading. Let's say whatever input image we'll be taking up, we are going to perform a rectified linear unit activation on it. I've already told you why we would be using rectified linear unit activation over sigmoid, because we'll be able to represent a lot of features in rectified linear unit in comparison to the sigmoid representations. Okay. And finally, you're going to get an image somewhat like this, a compressed image. Is that clear? You're going to get something like this. So let's go for it. We'll be implementing this part. Are you all clear what we will be doing? Okay, so now is the time to code. Let's quickly proceed to collab.research.google.com. And let's get started with a new notebook. Let's quickly name this notebook as Auto-encoders. Okay, you can connect your workbook, and I hope everybody is ready. Okay, so what we will be doing, let me just draw a diagram here on the right hand side so that we'll take that along the code. I'm going to draw something for you here. Let's say we'll draw an encoder. Okay, and we are going to get the final decoded information. Diagram is not looking much better. Let me just organize it a little better. क्या ना डिजाइन अच्छा होना चाहिए, तो अच्छी फीलिंग आती है बनाने में. Okay, let's see. So what we'll be having, this is going to be our input layer. This is going to be our output layer. Okay, this is going to be our hidden layer. Okay, let's say we'll be having some images here. Okay, जो भी images होंगी वो देखेंगे हम कौन सी images हैं, और फिर images के बाद में फिर हम उनको reconstruct करेंगे. So ये process आप लोगों को clear है कि सबसे पहले आपके पास क्या होगा. You are going to perform an encoding operation. You will be having an encoder here, which will actually help you take from input to hidden, and then from hidden to output you're going to have a decoder, which you're going to design here. And let's just draw some arrows. So here we'll go from input to hidden, then from hidden to output. And what next we will have here, we got dimensions reduced. Okay, we're going to reduce the dimensions, and rest, in case if anything comes during the explanation process, I'm going to explain that to you. So let's go here. Let's get started with the concept. So as you all are pretty clear now, a couple of information I would like to give you. What is autoencoding? Autoencoding is a data compression algorithm where the compression and decompression functions can be represented into 3 important factors. Okay, and these 3 important factors could be, I can write that here. First, it is data specific. Okay, autoencoding is data specific. Second, autoencoding is lossy. And third, it can learn from the example given, and it can be used only in the cases where you have similar kind of data. Okay, so we perform automatic learning. Okay, or you can say learning through weights. Okay, learning through weights using the activation functions. So these are the three things. So what could be data specific? So data specific is something which means that they will be only able to compress data similar to whatever data they have been trained on. So suppose, let's say you have the input data of a brain tumor images. Okay. So if you have trained your autoencoder with the brain tumor images and you try to encode another kind of images or different images, uh, then it is very difficult for the autoencoder to decode it. Okay, with the model, you have to retrain the new images. I hope this is clear. So if you are using a specific data, let's say if you are taking a data of brain tumor, your model will only be able to predict the brain tumor kind of output. He will be only able to learn the features of brain tumor kind of images. Suppose if you give a dog image in that for the output or for identification of the improved layer from that, so it won't be able to identify the dog image initially until and unless you have trained your autoencoder with the image of a dog or any other animal like cat or anything like that. Okay, is that clear? So autoencoders are data specific. So that is a limitation as of now. But as soon as you progress further with other algorithms, you will find out the solutions to these problems. Okay. Second, they are lossy. So once you regenerate the data, which means that the decompressed outputs will be degraded compared to the original inputs. Okay, is that clear? I hope this is clear. So let's say once you have trained an autoencoder over an image, you have got an input layer. The input layer could be of, let's say, HQ, high quality. Okay, but your output layer would be of low quality. ठीक है, लॉसी होता है ऑटो इनकोडर. Now let's see. ठीक है, so let's quickly start with implementations, that how we are going to perform the concepts of dimensionality reduction, compression, denoising out of using this autoencoder model. Okay, so let's get started with a simple, fully connected neural network, and we are going to design the encoder and the decoder. So first thing which you guys will be using will be known as Keras. Okay, so let me take you to Keras initially so that you can understand all the documentation. I really recommend keras.io website, which offers a great documentation which can help you understanding various techniques which are implemented. Okay, so I'll keep the Keras documentation on one side of the in my tab in order to quickly refer various functions which we will be using. Now, what is Keras? Keras is the Python deep learning library. You may be thinking why we are using deep learning library, because all the algorithms and all the functions which we understand, they are already implemented. The most important part which we need to learn was how the activation functions work, how the weights are calculated, how we can generate visible states from the hidden states and hidden states from the visible states. So now we understand the concept. Now, what would be the difference? We will be applying the algorithms which we implemented in the previous 4 sessions by utilizing an existing class for that algorithm using the deep learning Keras library. And many of the cases which you will be seeing today, or else if you will be implementing on a real-time project, you'll be working in a company, you will be actually utilizing these libraries in order to find out solutions to various basic problems. Okay. Now let's see. So what is Keras? Keras is a high-level neural networks API written in Python and capable of running on top of TensorFlow, CNTK, or Theano. These are deep learning architectures, deep learning frameworks. And over that deep learning framework, we have an application programmer interface known as Keras, which is similar to your scikit-learn and NumPy and various other matplotlib libraries which we were using earlier for different purposes. For deep learning, we make use of Keras. Okay. Now, so it's pretty simple. In order to quickly install, you can make use of the installation command with pip. You can install Keras. though it's by default available. Now we will be starting with a lot of operations here. So now on the left hand side, you can see when you have to get started with Keras, let's say in case if you have to install on a local system, you can make use of installation of Keras using PIP. So that's pretty simple. You can make use of this command PIP install Keras, and you will get the Keras installed on your server. Let's say in case if you are using a custom AWS server later for your project, then you can install Keras using PIP. Once you got the Keras installed, then you can proceed with the next stuff. So if you have to learn about models, so there is a class known as model in Keras, which is very important. We will be making use of model class today. Okay. So within every specific class, there are a lot of functions which are also explained here. How to compile a model, how to fit the model, how to evaluate the model, how to predict using the model, how to train the model on batch. So all these functions I have already explained to you in previous 3-4 sessions, that how we actually define these methods. Okay, so the equivalent methods which we have already done. So here, let's say in case if you're calling about fit, we have already defined a function as train in the previous sessions. For prediction, we have defined the predict function. Okay, then fitting the generator and all these are like implementing the data on a batch. That means if you are passing multiple values, so that's fine. Then for get layers, we have also done a concept on run visible and run hidden, which we have done in the previous session on Boltzmann. In the Boltzmann session, we have done that run visible and run hidden. Okay, so they are the common implementation of the functions which we have already understood with perceptrons and the RBM. Now we will be using these APIs, and the only differences will be the implementation of activation functions and what kind of rates have been taken, what kind of dot products have been taken. So all these things will be new to you, and you can quickly explore them with the references here available in the Keras. Okay, so now okay, so let me just quickly erase that. Okay, now, so you can make use of important options like libraries here. You can make use of methods. Along with methods, then you have the layers based information available. In case if you want to view the layers, you can make use of a lot of classes available over here. Core layers is one of the important one, using which you can understand how we create the dense layers, how we create the input layers. We'll be making use of all these, how to apply the activation function, how to change the shape of the data which you will be providing. So all these things we will be using here. So flatten is something like normalization of your data, okay, so that you can represent it well and you can perform predictions. Okay, so these are the common things which you have already done with basic implementation of perceptron and all. Post that, you have the pre-processing classes available over here: sequence processing, text processing, image processing, calculation of losses, calculation of metrics. So Keras has all these options available over here. Then there are a lot of examples available here. Okay, recurrent neural networks, memory neural networks, convolutional neural networks on different data sets are available. Okay, one-dimensional convolutional neural network for test classification. So you will get a lot of application-based uh, algorithms and classes implemented, which you can take up and you can make use of that. So it would be much better. The better you understand this documentation, the better you are friendly with this website, the better you will be able to understand different types of neural network algorithms, and you will be able to implement them. Now, let's quickly get back here to the encoder. So how we are going to do that? Let's just quickly get. So what you can do is you can use PIP install Keras in case if you don't have Keras available. So you can quickly check if the Keras is installed here. So I'm going to run a quick check on PIP install Keras. And if the Keras is available, it will say requirements are already satisfied. We do have Keras already installed. Okay, let's go for the next cell. So you can see that Keras is already installed. Now what is the second step? Let's import input and output empty layers using Keras library. Okay, so how we're going to use? We're going to simply use Keras with the name Keras. So first, when you create a neural network, what do you generally do? When you create a neural network, the first thing you do is you create the layers. Okay, so if I show you here, what do we need? We need to have this neural network. Okay, output layers and input layers. ये चाहिए हमें, यहाँ से ड्रॉ करता हूँ. Okay, we would be needing this, the input layers and the output layers. So for this, we have two classes available. From keras.layers, we'll import input and dense. And how do I got to know about it? I've already shown you the core layers of a neural network, and I'll take you to the documentation where you will understand how to relate and understand the document step by step. So this will inherit the quality within you to refer any document, understand what kind of classes and functions are available, and with you can relate the documentation with respect to your requirement, and you can match it with your thought process, so that you don't need to look for any code on social network in order to implement any concept on internet to find a algorithm to solve a problem. If you understand the concept well, if you have read the algorithm from Wikipedia itself, you will be able to implement that. Okay, that should be the capability which you all should develop within you. Okay, so try to understand each and every point, each and every layer, how everything is working, and then try to implement them. Now, so from Keras layers, I've taken input and dense, and how I got to know about it, I'm going to quickly show you. So here, when I came to the documentation, I got to know about the layers, and I have gone to core layers. Okay. So under the layers, the first thing which I do in a neural network, what would I do? I'm going to create a neural network with input layer, hidden layers, and output layers. And initially, whenever we create a layer, the responsibility of a developer is always to create an input layer and an output layer. The algorithm which you will be using, he will be responsible to create the hidden layers on its own. Okay. Now, so we have got various classes here. One class is dense. What is dense? Let's see. So dense implements the operation output equal to activation of dot product of input comma kernel plus bias. Okay. So if you guys can relate with the previous sessions, whatever we have created. So for activations, we have already defined, we used to call this as sigmoid function, and you guys have already implemented the sigmoid function. The only difference here is weights are known as kernels. Okay. In the demonstrations, in the previous sessions, we have been using weights, learning the weights. But in Keras, weights are known as kernel. Okay. So don't get confused what a kernel is. Kernels are nothing but the weights. And these weights will be random weights generated using a random function. Okay. So what is activation? I hope you all understand what is activation. So activation is the element-wise activation function passed as the activation argument. Kernel is a weights matrix created by the layer, and bias is a bias vector created by the layer. Okay, and this will be only applicable when the bias is true. So there will be an input value here, use bias equal to true. In case if you have specified use bias equal to true, bias will be automatically taken. It would be 0 when initially you are going to design it. Okay. Then you have got the activation function. In the activation function, you can define, do you want to use ReLU, the rectified linear unit, or do you want to use sigmoid? Okay, you can define that. Along with that, you're going to have the units. What would be the units? Units would be something like the number of neurons you would like to create in order to represent the states of the features or whatever it is. Okay. So you can see that if the input to the layer has a rank greater than 2, then it is flattened prior to the initial dot product with kernel. That means it's going to be normalized if the rank is greater than 2. So let's say if there is a 3-dimensional matrix given, then it is going to be flattened to a 2-dimensional data first, and then it will be multiplied with the kernels. Before you perform an activation on it, it is going to be converted into 2 dimension. It just means that. Okay. Now let's see. So this is dense. So dense is something relevant to output. Okay. But what we do need is, initially we need to have the inputs first. Okay. So let's go to the input function also. So in the code layer, I've got dense. Apart from dense, I need the activation. So activation, you already understand, activation is a class and you can pass the activation, the name of the activation which you want to use. You can quickly go to activations here, where you will get to know about different activation examples available. So here, these are the available activations. ELU is an activation. You have softmax algorithm available as activation. You have scaled exponential linear unit as available, and the formulas are also given there. Okay. So there are various activation functions available. It's not just sigmoid. There are various options available. Soft plus, soft sine, RELU, which you will be using today. Okay, rectified linear units, which is going to select the max value out of the value provided. So the function is max of x comma 0, which I have already discussed with you. X is going to be the input value, which is going to be provided. Followed by tan h, sigmoid. Sigmoid you have already implemented, 1 divided by 1 plus exponent to the power minus x. So now you can relate. In case if in the previous neural networks, if you guys want to modify, or if you want to use any other activation function, you can just go to, you can just define an activation function and provide the formula. Okay. So you have already implemented sigmoid, and I think it's much relatable to you all now that what these activation functions are. These are like different formulas which can help you activate a neuron on a hidden layer, and then using the input hidden layers, you can activate the output layers. Okay, so these are just various activation functions available which you can use. Now, so we will be using a couple of activation functions today also, which will be your RELU and the sigmoid. Okay, followed by, now what we have is, next I have to show you the input which I have taken. So the input is something like a very simple input function. Just you need to call the input instance. What this input is going to do, it is used to instantiate a Keras tensor. Okay. So what is the Keras tensor? You can quickly consider it as an object. Okay. Keras tensor कोई खास चीज नहीं है, एक सिंपल ऑब्जेक्ट है. आप समझ सकते हो जैसे आपने कोई एक वैल्यू लिया है, मान लो जैसे हम मूवी ऑब्जर्वेशंस डेटाबेस ले रहे थे, उसमें हमने एक सैंपल रो उठाया जिसने कुछ मूवीज देखी थी, वो 1 थी, जो मूवीज नहीं देखी थी वो 0 थी. तो अगर वहां से मैं एक न्यूरॉन वैल्यू लेता हूँ, लेट्स से 1, ठीक है, और मैं उन सारी वैल्यूज को पहले इंस्टेंस को मैं इनिशियलाइज करता हूँ एक पहले टेंसरफ्लो के इंस्टेंस को. दैट मीन्स कि मैंने पहला केस जब इनिशियलाइज किया, मैंने एक इनपुट लेयर बनाई, तो उस एक इनपुट लेयर को बनाने के लिए मैं इनपुट क्लास का कॉल करूंगा, उसका कंस्ट्रक्टर कॉल करूंगा, and it is going to construct me an input layer, and it's going to give me an object in the memory, and within that, with using that object in the memory, I will be able to store some values, let's say the neuron values, on those memory locations. Okay, so input is nothing, it's just a object which can help you create an input layer with the n number of neurons which you want on the input layer, depending on the states or depending on the features available in your data. So you can take accordingly. So you can initialize the input. Then there are various options here. You can define the shape of the input, that how would you like to represent your input. So let's say I say I have an image which is of 1200 cross 600 pixel size. So how many inputs I would be needing? I need 7,20,000 inputs. So within this shape, I have to define 7,20,000 as the shape of that. Okay. So something like this we will be doing in today's session, so that you will be able to understand how we can actually make use of these frameworks and these classes and functions in order to implement the concept of auto-encoding. Okay. So now, I hope this is clear. So you got to know what is a shape of an input. It is going to be the number of features which you will be taking. So जब हमने पहले फीचर्स लिए थे, जैसे मूवी डेटा सेट लिया था, उसमें हमारे पास 6 मूवीज थी, तो 6 फीचर्स थे. तो यहाँ पे अगर हमें एग्जाम्पल डिफाइन करना होता by using the previous example of the movie data set, तो हम यहाँ पे ऐसे डिफाइन करते हैं, shape is equal to and 6. Okay, kind of this we would have defined it 6. But in case अगर हम image processing कर रहे हैं, तो image processing करते समय हमें shape कैसे define करना पड़ेगा? We have to define the number of shape with respect to width pixels into the height pixels. Okay, जितने pixels होंगे वो हमें डिफाइन करना पड़ेगा. तो मान लो अगर आपकी एक इमेज, जैसे आज की जो हम इमेज लेने वाले हैं, वो 28 क्रॉस 28 पिक्सल की है. तो आप 28 क्रॉस 28 पिक्सल जब आप मल्टीप्लाई करोगे तो आपके पास एक वैल्यू आएगी 784. यानी उस इमेज को आप 784 रिप्रेजेंटेशंस में रिप्रेजेंट करेंगे, एंड दैट you have to initialize as an input layer, and within that input layer on every neuron you are going to have one value. So input shape is going to create an input layer for you. I hope this is clear to everyone. And just to remind you, though I have shown the video, one video on the first session, I would like to quickly show you the video again so that you guys can quickly relate what I'm saying here with respect to layers. So I think I have shown this video to you earlier also. Let it just quickly load, and I'm going to define the layers for you here, I guess. Yeah.
And before jumping into the math for how one layer in the image, that
here is the video. Let us just quickly see that. Okay, so here we have. So if you guys can quickly see, let's say we have an image of 9 here, suppose. Okay, so this image of 9 has been taken from the MNIST dataset, the dataset which we will be using, and it's a very common dataset. Why I'm using that dataset? Just to give you all a feeling that you can relate with the existing tutorials and what all people are working on. But this is a very basic example MNIST dataset. I want you all to be working on some real data so as to get the real work done. So this image has been taken from an MNIST dataset, which is by default available with all with the Keras framework and for your analysis purposes, so that you can understand. Now here, so here is an image represented, and the size of this image is 28 cross 28 pixels, so 28 pixel height and 28 pixel width. So that means you will be having the width of 28 pixels, which means you have 28 numbers who will be representing value between 0 and 1. Similarly, you will be having 28 values here, column wise, which will be representing any value known as the neuron value, which could be any value between 0 to 1. Okay, you're going to get that. So you can see that once you multiply 28 cross 28, you guys are going to get a value 784. Okay, so that's what I'm saying. When you have to define an input layer, you have to define the shape of 784 size. Okay, I hope this is clear. So depending on the number of pixels, depending on the height and width of the image, whatever you will be processing, you're going to take an input layer, which is going to create that many neurons in the input layer, and then you will be able to start processing. I hope this is clear that what we will be taking. Okay, so I'll just quickly run the video so that it is clear to all of you again. Okay, here. So let me just run that for you. Okay, here. So once you multiply 28 cross 28, what will happen? We are going to get a neural network of all these 784 features, and we are going to take it as an input layer. Okay. So now if you guys consider, this becomes your input layer. So this input layer of all these 784 features, you can actually create with the class input. So you can initialize the input using the input class, and by providing a value of shape, okay, and the shape you can define with 784 like this. Is that clear? You can initialize an input layer with this. Please confirm me on chat if this is clear to all of you. Please share the link of the article that you were showing. Okay, which article?
Which you were showing before this video which you are showing right now.
Okay, I'll just show. Okay, is that clear? Till here, this is clear to everyone? Okay, great. Now let's see. Let's get back to the main function. So, are you talking about this article?
Yes.
I think I've already shared that on chat with everyone.
Okay.
Again, I'm just sharing that. Everyone in meeting, command B here. Okay, last time it was sent to Subham Ghosh only. Now I have forwarded this with everyone. Okay. Now let's get back. So guys, you all are clear that we have taken inputs and dens. So, and you now understand why do we need input, why do we need dens. Okay. Let's get back to the code now. So we got input and dens. Similarly, we're going to make use of model. So from keras.model, we are going to import the class model. Okay. So where is that? Let's have a look. So now here you are going to get the models also. So let's just minimize the core layers. And after the core layers processing, we are interested of having a model. So that will be available at the top here, models. Okay. So there are two types of model. Either you can directly build a sequential model. Okay. You can directly build a sequential model. You can read about what a sequential model is with some basic values of inputs, matrix, loss. But I would recommend to go with the custom, the functional API wherein you can create your custom models. Okay. Now what this will do? So model class API, this will give some input tensor. So what do you understand about tensor? Tensor is just a neuron, you know. What is input tensor? It's a neuron. So you're going to give some input neurons and you're going to get some output neurons. Okay. And using this, you can instantiate a model. That means you can define the input, you can define the output, and using that, the model is going to learn. It is going to adjust the weights. Do you remember how we have done that with the perceptrons? We have defined a function known as train. We have given the values of x and y. I'm talking about the first case which we implemented with movie observations data, where you have specified x and y, which was the data which we have read from a CSV file. So similarly, here the name of the class is model. So don't get, sometimes people get pretty confused with these terms, like what is a tensor? I cannot understand what is a tensor. So tensor is very easy. Tensor is nothing but a neuron for you. Since you guys have implemented all of these things practically, so I believe your understanding of the concepts will be way too better with other people, those who are just reading the blogs about TensorFlow and not understanding what is happening in the background. Okay. So I really believe that you guys have that added advantage that now you can understand everything, that what is a neuron, what is tensor. Tensor is actually a neuron. And what is the model doing here? The model is just like training your model, training your artificial neural network by providing him the input and output. And using this input and output, you're going to generate the weights. You're going to adjust the weights. And the weights which will be adjusted will be used in the next iteration or in the next prediction, where you will be providing the new data, the new case, and you're going to get the output. Okay, I hope this is clear to everyone. ओके रिलेट कर पा रहे हैं आप लोग? बताइए जरा मुझे चैट पे, समझ पा रहे हैं आप लोगों को ये एपीआई मुश्किल तो नहीं लग रही है केरास की? क्या आप लोगों को ऐसा लग रहा है कि हाँ ये सब तो हम ऑलरेडी कर चुके हैं, हमने खुद बनाए हैं कोड न्यूरॉन्स के, लेयर्स के एंड ऑल दैट? क्योंकि अगर आप उन चीज़ों से रिलेट कर पाएंगे तो फिर आपके लिए बहुत इजी हो जाएगा कि आप कोई भी एल्गोरिथम यूज करके किसी भी प्रॉब्लम स्टेटमेंट को बेझिझक होकर सॉल्व कर सकते हैं. ओके, नाउ लेट्स सी. चलिए आगे बढ़ते हैं. तो मॉडल्स के बारे में आप समझ चुके हैं. मॉडल्स की कोई बहुत खास बात नहीं है. मॉडल इज जस्ट अ क्लास, द वे वी हैव बीन डिजाइनिंग अवर क्लास. जैसे हम बता रहे थे माई न्यूरल नेटवर्क, आरबीएम, जो क्लासेस हमने बनाई थी, वैसे ही सेम यहाँ पे मॉडल क्लास है. उस मॉडल क्लास को हम इनपुट वैल्यूज देंगे, आउटपुट वैल्यूज देंगे. डिपेंडिंग ऑन दैट इन्होंने अलग अलग फंक्शंस यहाँ पे डिफाइन कर लिए हैं. जैसे एक फंक्शन इन्होंने कंपाइल डिफाइन कर दिया है जिसमें वो वेट्स डिफाइन कर रहा है कि वेट मैट्रिक्स दे दो. ठीक है. Similarly, you have got the fit function, which I already told you. This is known as the training. So fit is equivalent to training, where you are going to provide the independent variables, the dependent variables, the epoch. Epoch is something like the iterations, the number of iterations which you want to use. Along with the validation split is something like distributing the data, splitting the data into test training and the test cases, so that you can train with some values of data and you can test from other values of data, so that you can establish authenticity of your algorithm, that yes, the accuracy is correct, because the model works because you have not fed the data while training. So there are these are basic attributes which are taken in every specific function, so as to make an optimized function, so that you can get better performance while executing your code and everything. So these are the common functions which you will be using: fit, predict. All of these you have already implemented. So let's just quickly go and let's start the code. Okay. So guys, let's run this cell. Let's import Keras layers, input, dense, and model. Now what do we want? Okay. So I will say I'm going to get a data. Let's say I'm going to receive the MNIST data set, which I've already shown you. We will be using the MNIST data set. MNIST data set contains an images of characters between 1 to 9. Let me just show you the MNIST data set. MNIST data set. Okay. So here, the MNIST dataset looks somewhat like this. There's an example MNIST dataset. Okay, let's say here on machine learning mastery, we have got an image. Let's see like this. So you're going to get the dataset like this, and what this dataset contains on the x-axis as well as on the y-axis. Okay. So let's say if we talk about the pixels, these are 88 pixels. Height is of 28 pixels and width is also of 28 pixels. Okay, this is the MNIST dataset for you. So once you will be representing this 28 pixel cross 28 pixel, you will be having the information about 784 neurons, as well as you can also call it as tensors. Okay, neurons and tensors. Okay, 784 tensors. So initially what we are going to do for the input layer, we will be defining 784 tensors here. Okay, we'll be having 784 tensors within this input layer. So let's go for it. How we are going to do that? So initially we are going to design these many tensors, and how we can do that. It's pretty simple. I've already told you. You can make use of the input class. Okay. You can make use of input class from Keras, and you can see that input is used to instantiate a Keras tensor. What is the Keras tensor? Keras tensor is a input layer which contains a number of neurons, and it is based over TensorFlow. That's why we are going to get the tensors. And for instance, if you have taken a model instance as A and B, whatever the values you will be taking in input and whatever value you will be taking in output, so every value within a row for a specific column will be treated as a tensor. We generally call them as variable in machine learning, but when it comes to deep learning, it is known as tensors. Okay. Nothing but just to confuse the normal people that what tensors are. Okay. And I'm not confusing actually. The algorithm designers are confusing. I must not say that. Just to keep the brand value, since they are having a tensor flow. So tensor flow is just like the flow of a neural network. Okay, with the input layers and the output layers, and they don't call it as a neural network. They call it as a tensor flow. And within TensorFlow, you have all these neurons which will be flowing from input to output. Hence, they call every neuron as a tensor. So that's the motivation behind it. Now let's see. So you're going to get an input. And as I already told you, you're going to create an input of the shape of size 784. And why are you creating this with 784 size? Because the input image which we will be taking is of 784 cross 784 pixels. So as of now, the image which the input layer which I will be creating will be having 784 neurons in it, with each neuron having a value 0 initially, until and unless I load that with an image. Okay. Is that clear? I hope this is clear to everyone. Now what we're going to do? Let's just quickly execute that. We're going to get the input. So this is how we create the input image, and this is an object. You cannot see the values like the way we were visualizing that in our what we say in our custom classes. You cannot visualize it here that way. You cannot see the matrix. So it's always advised to understand the matrix part and the input part and defining of the function first, and then using these APIs and these libraries. Otherwise, you will miss out a lot of background work which happens. So here we have the input image. Even though if you want to print a detailed variable option here, so you can implement VARs on that so that you can see the content within this input image. So with this object, you can see that it's nothing but it's an input placeholder. Okay, it's stored at an index 0. The data type is float 32. The output will be a TensorFlow output. That means it's going to be an activated neuron, which is stored at this memory place. Okay. Then you have the shape value. Okay, you have an ID for that. You don't have a name for this variable as of now. The shape of the Keras is 784 inputs we have taken. Okay, along with no, we are not using any learning phase at the moment. So this is the overall display of the object. So earlier we used to generally we defined values when we initialize the constructors, but here we only have one property value index which you can run, which actually defines 0, which means its value within that complete network. So here they have not defined any specific function to view the matrix of input image, so you cannot do that here. Okay, so just you have to imagine in your mind.
Hello sir.
Hello, yes.
जी सर, एक क्वेश्चन है, ये कैसे रिकॉग्नाइज करेगा जो
Sorry,
ये रिकॉग्नाइज कैसे करेगा सर अपना ये टेंसर की ये 28 क्रॉस 28 ही होगा हमेशा?
I cannot understand. Could you speak a little loud, please?
सर ये 28 क्रॉस 28 ही होगा हमेशा, कैसे रिकॉग्नाइज होगा? मैंने तो 784 लिख दिया है.
आपकी बात नहीं क्लियर हो पा रही है। 28 क्रॉस 28 कैसे रिकॉग्नाइज करेगा, समझ में नहीं आई मुझे बात।
सर 784 is a multiplication of 28 into 28.
या
लेकिन ये उसे कैसे पता चलेगा कि हमेशा हम जो हाइट और विड्थ ले रहे हैं वो 28 और 28 ही ले रहे हैं? ये
किसे
हमें
किसे पता चलेगा, मतलब
सिस्टम को ये हमें आगे स्पेसिफाई करना होगा शायद।
हाँ, वो तो जब हम इनपुट इमेज लेंगे तो हम कोई भी एक इमेज जब रीड करते हैं तो उसका हम शेप चेक कर लेते हैं। उसके शेप में हमें उसके रोज और कॉलम्स मिल जाती हैं कि कितने पिक्सल्स विड्थ है, कितने पिक्सल हाइट है। तो बहुत सिंपल सी चीज़ है, आप कोई भी एक स्पेसिफिक इनपुट इमेज लेंगे, आप उसका हाइट विड्थ चेक कर लेंगे, आपको उसका पिक्सल साइज मिल जाएगा। तो आप उसके पिक्सल साइज का प्रोडक्ट ले लेंगे, आपको ये वैल्यू मिल जाएगी। इज दैट क्लियर? Is that clear?
Okay.
Yeah. So once you read an image, आप जैसे आप कोई भी लिस्ट लेते हो, कोई भी स्ट्रक्चर लेते हो, कोई भी डेटा स्ट्रक्चर आप लेते हो, तो आप शेप कॉल करते हैं उसके ऊपर, आप उसके रोज और कॉलम्स मिल जाते हैं। सिमिलरली व्हेन यू आर गोइंग टू टेक एन इनपुट इमेज, आप उस इनपुट इमेज का शेप चेक करेंगे। जैसे आप उसका शेप कॉल करेंगे उसका वैल्यू, तो आपको उसकी रोज और कॉलम्स मिल जाएंगी। एंड रोज एंड कॉलम्स विल एक्चुअली डिफाइन कितने पिक्सल्स विड्थ वाइज है और कितने पिक्सल्स हाइट वाइज है। तो सिमिलरली आप ये प्रोडक्ट कैलकुलेट कर सकते हैं। ठीक है? So now, so this is how it can be recognized. Now let's see. Let's go for the next segment. Input हमने बना लिया. Now what do we want? We want to have a densely connected neural network. I have told you we want to create a fully connected neural network. So with this input layer, we want to connect a hidden layer. Okay. That means now I am working on this part. Let me just what I want to do a hidden layer. Okay, so this is going to be my dense network, a connected network. I hope this is clear. This is going to be my connected network. And how do we create a connected network? We create a connected network using the class dense. Okay, so what it does, this is your regular densely connected neural network. So dense implements the operations output equal to activation of dot product of input variables, which are provided from the input layer, multiplied by the weights, which are random weights, which are already defined when you initialize your model, or when you initialize the model, in fact, plus the bias. Okay, so this, what it will do, out of your 784 values from the input image, we are going to read every pixel. We're going to get the value of every pixel. We are going to multiply that with a weight, and we are going to get an activation function. And depending on activation function, we are going to activate some values on the hidden layers. Okay. So now within this dense, first we have to define the units. Okay. We have to define the units. So now I will say I have got 784 neurons, but now I would like to compress it. Okay. Let's say I say out of this 784 neurons, I want to identify, I want to make a picture of 16, let's say 32 neurons. Total एक 32 bit का मैं image बनाऊंगा. Okay. So what I'm going to have, let's say I'll say that I will be having a 32 neurons here. Okay. We'll be having 32 neurons in the hidden layer. Now, what does that mean? We are going to reduce the dimensions from 784 to 32. That's what we are going to perform. Okay. Is that clear? So from 784, we are going to make a 32 dense network. So how we are going to create that? You have to define the units. Okay. I'll just show you. First value would be the units. So I will say I'm going to define 32 neurons on the hidden layer, followed by I'm going to have, second, it is asking me for an activation function. You already understand what is an activation function, and I've shown you various types of activations options which are available. Activations like ELU, activations like sigmoid, activations like rectified linear unit. There are various activation functions available. Okay, so I will be taking an activation function RELU, and you will be asking why I will be taking that. I have already told you that ReLU will be able to represent these 784 features appropriately. And then out of all these 784 features, we will be able to distinguish between every important feature, and we can select the important features and we'll put that into the hidden layer, into the 32 neurons which we have taken on hidden layer. So you can take any number of neurons on hidden layer, any number of neurons less than 784 will decompress it. In case if you want to improve the image, if you want to improve the quality, then what you can do is you can represent that from the number of neurons on the hidden layer greater than the size of the input layer. So let's say अगर आपके पास input में 784 है, आप dimensions बढ़ाना चाहते हैं और क्वालिटी इंप्रूव करने के लिए, तो 784 से आप हिडन लेयर पे मान लो आप 1000 न्यूरॉन्स कर देते हो, ठीक है, तो आपकी हिडन लेयर पे 1000 न्यूरॉन्स होंगे, तो अब आप और भी ज्यादा डायमेंशंस एक्सप्लोर कर सकते हैं, ठीक है। तो अगर तब जो आउटपुट जनरेट होगा एक हाई क्वालिटी आउटपुट जनरेट होगा। बट अगर आप डायमेंशंस रिड्यूस करना चाहते हैं तो आप इनपुट लेयर से कम हिडन लेयर्स पे न्यूरॉन्स आइडेंटिफाई करेंगे। मैंने रैंडमली एक ले लिया है 32 बिट। ओके, इज दैट क्लियर? नाउ so I am going to have this activation function ReLU, which means I am going to take a max value for these 32 layers, okay, and whichever value is greater. अगर input image की कोई value बड़ी होती तो वो आ जाएगी और नहीं तो 0 आ जाएगा। So I am going to multiply that with the input image. So now this is your multiplication of input with respect to weights and bias defined in the activation ReLU, and you're going to get a fully dense connected network. And let's just quickly save that into an encoded network. So once your encoding is done, you're going to quickly save that into encoded. Is that clear? यहां तक अगर आप लोगों को बात समझ में आ गई है तो मुझे बताइए। ओके, ठीक है, समझ में आ रहा है, मजा आ रहा है, इजी है, कॉम्प्लेक्स तो नहीं हो रहा, बहुत आसान आसान सी चीजें हैं, इट्स वेरी इजी। वी आर जस्ट मेकिंग अवर कंप्यूटर्स लर्न द वे वी लर्न, दैट्स इट, इट्स नथिंग बिग, even though it's pretty big for other people, those who are not from computers background, but it's very easy for us. Okay, now let's see. So once we understood this, that we have created an encoder network now. Okay, we have got a densely connected encoder network which takes 784 pixels, which is a dot product of 28 cross 28 from the image of an MNIST dataset. विनय सर को मैं एक बार दोबारा बता दूं, MNIST dataset के अंदर जितनी भी images हैं उनका साइज 28 cross 28 पिक्सल ही है। बट अगर आप कोई दूसरी इमेज लेंगे तो हम ऑटोमेटिकली जब उस इमेज को रीड करते हैं तो उसकी हाइट और विड्थ हम चेक कर लेते हैं, ठीक है, कि क्या उसकी हाइट है, क्या उसकी विड्थ है। इफ यू वांट टू सी एन एग्जांपल दैट हाउ वी डू दैट, let me just quickly show you that how we actually calculate the shape or size of an image. Okay, so here I'll just show you. Okay, see, here is a simple function of checking the image size. So let's say using a class image.open, I have read the content of an image. Let's say the image is coming from a URL or from anywhere. Okay, what we can do, just with the logo IM with the object, we can quickly check the size and we get the height and width of the logo. Okay, now using that logo height and width, you can take a product and you will be able to calculate the number of pixels required at the input layer. कितने number of neurons आपको input पे चाहिए। Is that clear? अभी हमें known था MNIST data set, इसलिए हमने directly 28 into 28 का value हमने ले लिया। Is that clear?
Okay, sir. Yeah.
तो यहाँ पे एक library हम use करते हैं, that is an image library, and I'll quickly show you what that image library is. Okay. Here is the way you can use PIL to import image, and from that image you can call the function open. You can read the bytes data, or you can read the file directly from a URL or from a local path, and then you can get the size of the image. Is that clear?
Thank you.
Now let's go for the next network. So अब आपने encoder तो बना लिया, अब हमें क्या बनाना है? अब हम decoder बनाएंगे. Okay, now we are going to make a decoder. So in order to make a decoder, now what do you need? You need 32 layers would be your inputs, and for the output you are again going to create a densely created network. So output this time, what do we want? Let's say we want to regenerate those 784 features back, okay, out of the 32 features which is available in the dense, which is available in the hidden layers. So again, I'm going to create a fully connected neural network. So we can create a fully connected neural network using the class dense. And in the output, now what I want, let's say I want to generate 784 features again. So ये 784 features अब कहाँ पे generate हो रहे हैं? यहाँ पे output layer के 784 features हैं, which we are actually trying to generate from the 32 features. Okay, यानी over the internet, let's say जब हम data transmission करेंगे तो हम 32 layers ही transmit करेंगे, 32 neurons ही transfer करेंगे. तो क्या होगा? साइज कम होगा. नेटवर्क पे जब हम 32 बिट का पैकेट भेजेंगे, मान लीजिए, तो वो बहुत छोटा होगा, ठीक है ना, 784 बिट के हर पैकेट के कंपैरिजन में. सो होगा क्या कि वी विल बी एबल टू डिलीवर मोर डेटा विद लेस कंजम्पशन ऑफ डेटा, एंड एज सून एज इट रीचेस टू द डेस्टिनेशन, वहां पे हम दोबारा रीजनरेट कर लेंगे 784, यानी डीकम्प्रेस कर लेंगे, तो हमारे पास दोबारा फीचर्स जनरेट हो जाएंगे, एंड वी कैन यूज दैट इमेज. ओके, काइंड ऑफ दैट. So अभी हम दोबारा से 784 यूज कर रहे हैं on the output layer, and we have to define the activation. Okay, so जब आप number of smaller layers से जब आप bigger layer आप define करते हैं, तो आप यहाँ पे sigmoid define कर सकते हैं, ठीक है, because अब आपको जो activation करना है, आपको इन 32 features के basis के ऊपर वही activation अब आप ऑलरेडी लर्न कर चुके हैं, जो भी आपके पास इंफॉर्मेशन है, ठीक है. नाउ यू आर ट्राइंग टू कैलकुलेट द फीचर्स एंड जो कि 0 और 1 की रेंज में आप रिप्रेजेंट कर सकते हैं, क्योंकि 32 इज अ वेरी स्मॉल वैल्यू, एंड जब आप डिकम्प्रेस कर देते हैं तो वो बहुत छोटी हो जाती हैं वैल्यूज, ठीक है. तो डिकम्प्रेशन करने के बाद छोटी वैल्यूज के लिए हमें रेक्टिफाइड लीनियर यूनिट की जरूरत नहीं है, बिकॉज वी डोंट नीड टू रिप्रेजेंट अ बिग इंफॉर्मेशन. ओके, सो दैट्स व्हाई वी यूज सिग्मॉइड while we decode. Okay, so अब जब आप decode करेंगे तो आपके पास एक encoded image के साथ अब आप इसका product ले सकते हैं, ठीक है. So what we are going to have, जो हमारी 32 हो गया, और इसको हमने किसके साथ में multiply कर दिया, 784 जो हमारी output neurons होंगे with, and they will be activated using the sigmoid function. So let's just quickly save that into decoded. ओके, तो ये हमारा अभी एक बेसिक हमने सेटअप बनाया है एनकोडिंग और डिकोडिंग का. ओके, सो अब मैं कहूँ कि पूरा का पूरा ऑटो एनकोडर मुझे बनाना है. नाउ कलेक्टिवली आई वांट टू मेक एन ऑटो एनकोडर. सो हाउ विल आई मेक एन ऑटो एनकोडर? आई हैव टू जॉइन बोथ ऑफ देम, द इनपुट एंड द आउटपुट. सो इन ऑर्डर टू डू दैट, हु विल हेल्प मी? द मॉडल क्लास विल हेल्प मी नाउ. ओके, सो विद इन दिस मॉडल, first of all, I'm going to take the input image which I have defined, and I'm going to get the decoded image. So I will be able to compare the input provided, the high quality image, and the low quality image generated. And let's just quickly save that into Auto-encoder. Okay, is that clear? So we got our first Auto-encoder ready. And using this autoencoder, you can actually now see the layers, because in a model we do have a lot of options. We have layers, we have a lot of values, the weights and everything. We have the calculated weights. We can represent all here. So मान लीजिए मैंने अभी autoencoder run किया है, और autoencoder run करने के बाद you can quickly see a lot of options. You can see ये तो addition की option options हैं, but some of the important for you to view the values would be something like get the layers, fit, okay, get the weights, you can check the weights, you can check the layers, you can check the metrics, you can check the kernel, okay. So these are, you can check the output shape, all these things you can actually do. So it's a good idea that you can actually explore. So here I want to view the layers. So if I run that, so now you will be able to, let's just print the matrix. I have got 3 memories. We have got 3 layers within this autoencoder. Layers के अंदर भी कोई information है? Layers के अंदर हमारे पास, okay. Let's just try to print that. Print, let's say in case. नहीं, वेरिएबल नहीं है ना, चलो ठीक है, मैं भी आपको दिखाता हूँ. We'll just quickly refer the documentation and we'll see कि कौन सा specific method है जिसके थ्रू आप weights and all सब चेक कर सकते हैं. weights वैसे आपको यहाँ से दिख जाएंगे. इन्होंने weights I think रिटर्न किए होंगे, weights. हाँ, तो we do have the weights here, जो जब आप images देंगे, images देने के बाद जब वो learn कर लेगा appropriate weights, तो आपको weights की matrix मिल जाएगी, ठीक है. और weights को हम क्या बोलते हैं? हम kernel बोलते हैं. तो यहाँ पे हर लेयर का इंफॉर्मेशन है आपके पास. So here we have the information about the kernel. The shape is 784 to 32. That is your first layer. 784 से 32 पे आप जा रहे हैं, ठीक है. फ्लोट टाइप की एरेज हैं, 32 बिट्स की हैं. फिर उसके अंदर आपने किया क्या है, आपके पास वेट्स अवेलेबल हैं, ठीक है, फॉर ऑल द 784 वैल्यूज. सिमिलरली जब आप सेकेंड लेयर पे आते हैं तो सेकेंड लेयर आपका 32, ये हिडन लेयर है आपका, 32 न्यूरॉन्स का है. उसके यहाँ पे अभी एम्प्टी वेट्स डिफाइंड है, ठीक है. फिर थर्ड लेयर पे हमारे पास हम 32 से 784 में कन्वर्ट कर रहे हैं और उनके कर्नल, वी विल कॉल देम एज कर्नल, ओके, वो डिफाइंड है. वेट्स भी बोल सकते हैं, कर्नल्स भी बोल सकते हैं. वी हैव द वेट्स आल्सो डिफाइंड, ओके. सो दिस इज हाउ, this is just the basic setup of the model. We have not taken the images as of now, so it's not working, but just to explain you कि overall process क्या होता है, वो आप लोगों को समझ में आ गया होगा कि ऑटो एनकोडर एक्चुअली में करता क्या है. पहले एनकोडिंग करेगा, फिर डिकोडिंग करेगा, और ये जो पूरा प्रोसेस है उसको हम ऑटो एनकोडर बोलते हैं, ठीक है. अब हम चलते हैं आगे. अब हम एक्चुअल इमेजेस को यूज करके एक काइंड ऑफ एक प्रोडक्ट बनाते हैं. Okay, till here everybody is clear? Are you all done till here? Please confirm me on chat if you all are done till here, so that we can proceed to the next step. Okay, now let's see. चलिए अब स्टार्ट करते हैं. So let's say now we are going to test it on images. Test it on images from MNIST data set. So what we can do, Keras also offers you data sets. Okay, you can quickly import data sets, and from this you have various options. There are various data sets available. हमने जो यूज करना है वो है MNIST डेटा सेट. ओके, काफी सारे डेटा सेट्स हैं केरास के अंदर. तो हम एक, अभी हमने अपना कस्टम डेटा सेट लेने के बजाय हमने MNIST का डिफॉल्ट डेटा सेट हम ले रहे हैं, जस्ट टू क्विकली टेस्ट द इंफॉर्मेशन. अब देखिए, तो आप इमेजेस अब आप रीड करेंगे. वी ऑल्सो नीड numpy, बिकॉज आई हैव ऑलरेडी टोल्ड यू numpy की हमें क्या जरूरत पड़ती थी. हम डॉट प्रोडक्ट्स करते थे, ठीक है ना. डॉट प्रोडक्ट्स हम लेते थे, हम एक्सपोनेंशियल कैलकुलेट करते थे. ऑल दीज थिंग्स वी यूज्ड टू डू यूजिंग numpy, the mathematical library. Here also we will be using numpy for n number of operations. Okay, like once we will be taking the product of the training data, and then we will be taking the product of the testing data. All these things we will be doing, so you'll understand that how we do that. Okay, So let's see. So I'm going to call the object MNIST, and this MNIST has a function known as load data. Okay, there's a function known as load data. So what this load data will do, it will actually bring that, it will extract the data for you and will represent it. Let me just quickly run that and then I will show you the load data set option. MNIST dot load underscore data. Okay. So what this load data can do, it loads the MNIST data set. You can define the path of the data, and what it is going to do, it's going to return you a tuple of numpy arrays. Okay. क्या return करेगा आपको? ट्रेनिंग डेटा रिटर्न करेगा आउट ऑफ द एक्स एंड वाई वैल्यूज, और टेस्टिंग डेटा आपको रिटर्न करेगा एक्स टेस्ट एंड वाई टेस्ट के नाम से. इज दैट क्लियर? सो नाउ व्हाट वी कैन डू इज, लेट अस जस्ट क्विकली सेव दैट. ट्रेनिंग और टेस्टिंग भी हम यहाँ से ले सकते हैं, अदरवाइज व्हाट वी विल डू, अभी हम एम्प्टी ले लेते हैं ट्रेनिंग एंड टेस्टिंग, सॉरी ट्रेनिंग हम एक्स वैल्यूज हम ले लेते हैं जो वाई की वैल्यूज हैं, क्योंकि यहाँ पे कोई लेबल तो है नहीं, लेबल्ड इंफॉर्मेशन तो है नहीं. ठीक है, तो अब आपको करना क्या होगा, हमें सेम इनपुट की ही इमेज को रीजनरेट करना है. तो हम क्या करेंगे, सिर्फ हम यहाँ पे एक्स वैल्यूज लेंगे जो भी सारी की सारी इमेज वैल्यूज हैं, एंड देयर विल बी नो वाई वैल्यू हियर. सो व्हाट वी आर गोइंग टू डू, लेट्स लोड दैट डेटा एंड वी आर गोइंग टू सेव दैट इनटू, as it told, it's going to give you the tuple based information. So I'm going to take the value of x train, but I don't want to take a value of y as of now, as well as I'll take the values for test set and no values for y. Okay, so I have got x train and x test. यहाँ पे ऐसा हमने क्यों किया है, क्योंकि हमारे पास जो डेटा है वो अनसुपरवाइज डेटा है, अनलेबल्ड डेटा है. अनलेबल्ड डेटा से हम सिर्फ उसके एक्स वैल्यूज को रीड कर रहे हैं जो भी पिक्सल वाइज वैल्यूज अवेलेबल है. तो उसमें थोड़ी सी वैल्यूज हमारे पास ट्रेनिंग में आ जाएंगी, थोड़ी वैल्यूज हमारे पास टेस्टिंग में आ जाएंगी. ओके, एंड नाउ इफ यू वांट टू सी, लेट्स जस्ट रन इट, एंड इन द नेक्स्ट लाइन ऑफ कोड you can see it's downloading from Amazon AWS.com image datasets mnist.npz. यहाँ पे mnist का आर्काइव है, आप इसको डायरेक्टली भी डाउनलोड करके रख सकते हैं. ठीक है, 11.5 MB का टोटल डेटा है mnist.npz, और इसको आप एक्सट्रैक्ट करके रख सकते हैं आर्काइव को. npz का डीकम्प्रेसर आप डाउनलोड कर लीजिए. ओके, तो आप डायरेक्टली इमेजेस को भी देख पाएंगे. एक्सट्रैक्ट फ्रॉम npz. ओके, तो npz के लिए आपके पास कई सारे ऑप्शंस हैं. You can quickly check back here. ठीक है, so here what we have here is, let's say on Mac it shows me associate the npz file extension with the correct application on Mac. Right click the npz file and then click open with other, then choose the program and check always open with. अच्छा ठीक है, ये तो बड़ी अच्छी, बहुत बढ़िया बात बताई है इसने. ओके, npz एक्सट्रैक्टर वी नीड टू क्विकली डाउनलोड. ठीक है, आप डाउनलोड कर सकते हैं. विंडोज के लिए देख लीजिएगा, शायद 7G एक्सट्रैक्टर भी आपके लिए कर देगा. npz एक्सट्रैक्टर मैक. ओके, अच्छा सॉरी, वो तो मैट्रिक्स है. सो यस, आफ्टर ऑल वी कैन एक्सट्रैक्ट दैट विथ numpy. वो numpy का आर्काइव है एक्चुअली. ठीक है, npz इज समथिंग लाइक एन numpy आर्काइव. इट्स ऑलरेडी इन मैट्रिक्स फॉर्म. ठीक है, मैट्रिक्स के फॉर्मेट पे है, 1-0 के फॉर्मेट पे वैल्यूज हैं. सो देख लेते हैं हम इसको. वी आर क्विकली गोइंग टू रीड द वैल्यूज ऑफ एक्सट्रेन. तो लेट्स से अगर हम यहाँ पे एक्सट्रेन रन करते हैं तो आपको दिख जाएगा यहाँ पे आपके पास इमेजेस की वैल्यूज हैं. ठीक है, इट्स अ मैट्रिक्स. यू कैन make a print of all the values with the details. Let's say print vrs xtrain. Let's see what does it contains. So vrs doesn't work for xtrain here, not a problem. ये उतना ही आ रहा है, वो concatenate करके आउटपुट दिखा रहा है. In between you will be having the values of 1 also. Okay, not an issue. So we have got the training data as well as let's quickly check the testing data also for the MNIST images. वो भी इसी format के, ठीक है. Last values empty हैं. बीच में there will be some of the values जो कि 1 होंगी, ठीक है. जहाँ जहाँ पे 1 होंगी मतलब वो आपका नंबर रिप्रेजेंट कर रहा होगा. तो यहाँ पे अगर आप देखेंगे ये कंकैटिनेट कर रहा है, सारी वैल्यूज नहीं दिखा रहा है. सो डिटेल में आप एक बार चेक कर सकते हैं कि आप हाउ यू कैन क्विकली व्यू ऑल दीज वैल्यूज, ठीक है. नंपी एक्सट्रैक्ट करेंगे तो आपको मिल जाएंगी सारी की सारी वैल्यूज. नाउ लेट्स सी. तो अब मान लीजिए हमारे पास ट्रेनिंग डेटा अवेलेबल है और टेस्टिंग डेटा अवेलेबल है, ठीक है. सो इस ट्रेनिंग डेटा और टेस्टिंग डेटा को अब आपको करना क्या होगा, वी आर गोइंग टू नॉर्मलाइज इट फर्स्ट. ओके. सो इट कुड बी पॉसिबल कि जो भी वैल्यूज आपके पास आई हैं वो किसी भी नंबर पे हो सकती हैं. इट कुड have any value greater than 1 also. Okay. Somehow in this data set we do have the values between 0 and 1 only, maybe अभी हमने देखा नहीं है, लेकिन बड़ी भी हो सकती हैं, ठीक है. So what we have to do now is we have to normalize all the values between 0 and 1 and we will flatten the 28 cross 28 images into vectors of size 784. That's what we need to do. क्यों करेंगे हम, जितनी भी हमारी 28 क्रॉस 28 की मैट्रिक्स है वो एक वेक्टर बनाएगी 784 साइज का. तो हमें 784 साइज में हमें एक शेप में हमें एक एरे मतलब एक हमें वेक्टर बनाना है और उस वेक्टर की वैल्यूज जो होंगी वो 0 से 1 के बीच में होंगी, ठीक है. So in order to quickly do that, what we can do is we can actually normalize that and then we can take the training data, testing data, and we can make a product with shape and all, and then we can print those information. So let's just normalize the values. So what we are going to do, normalize the values between 0 and 1 and flatten the 28 cross 28 images into into a vector of size 784. That's what we need to do. Okay. So for this, what we are going to do, let's quickly take the training, simply call as type function. You can quickly identify the type of the value. So I have already checked it's float 30. It's integer type. By default, when you're going to download this information, it's going to be an integer value, 0 and 1. Okay, but since we have to represent that into a 784 vector, we need to convert that into float. Okay, so we are going to call it as a float 32 value. So let's represent the value as float 32 and divide by 255 so that you can represent the value between 0 to 255 and then you will be able to use rectified linear unit and this will become my training data, x underscore train. So now what am I doing is I'm flattening the image, means I'm converting the representation of images from 0 to 1 to 0 to 255 kind of. Okay. So let's just quickly print what's going to be the output of that. Let's print the X train. So we are dividing the values with some. अच्छा ये पहली starting की जो values हैं वो 0 0 ही हैं और ending की भी 0 है. यहाँ पे जो हमारा data type है वो float 32 है. Okay. Is that clear? Just quickly test that till here. Just convert the data type into float 32. I hope it is clear to all of you why we have used float 32, because initially the NPC data which we have downloaded was of integer type, but we have to represent these images into 784 vectors. So we converted that into float. Okay. Okay, I hope this is clear. One more thing, what we can do is, I'll tell you one more way. Let's just show the complete arrays using numpy. Okay, यहाँ पे आपको एक छोटा सा काम करना पड़ेगा. सिस्टम इंपोर्ट कर लीजिए आप और numpy इंपोर्ट तो हम ऑलरेडी कर ही चुके हैं। और यहाँ पे अब आपको एक काम करना पड़ेगा, np जो आपका ऑब्जेक्ट है इसके अंदर एक वैल्यू होती है सेट प्रिंट ऑप्शंस। ओके, सेट प्रिंट ऑप्शंस की वैल्यूज को आप सेट कर दीजिए। इसका जो थ्रेशोल्ड वैल्यू है दैट शुड बी सिस्टम डॉट मैक्सिमम साइज, सिस डॉट मैक्सिमम साइज, जितना भी स्पेस है हमारे पूरे मशीन का तो पूरा पूरा डेटा हम डिस्प्ले कर पाएंगे, मैक्स साइज। ओके, सो रन करते हैं। सो अब आपके पास ना पूरा जो भी एक्सट्रेन का डेटा है वो पूरा कंप्लीट 784 का जो भी इंफॉर्मेशन है वो कंप्लीट दिखाई देगा, जो भी इनपुट डेटा हमारे पास आया होगा सारे पिक्सल्स। ओके, सो टाइम लगता है इसलिए जुपिटर बाय डिफॉल्ट क्या करता है, ट्रंकेट कर देता है एरेस को, ताकि आपका मेमोरी कंजम्पशन ज़्यादा ना हो। अदरवाइज क्या होगा कि अगर आपके सिस्टम का मेमोरी भर गया ड्यूरिंग जस्ट बाय प्रिंटिंग दीज बिग एरेज, इट्स ऑफ नो यूज। सो बाय डिफॉल्ट वो प्रिंट ऑप्शंस को बहुत लिमिटेड रखता है, बट जस्ट फॉर टेस्टिंग मैं एक बार आप लोगों को दिखा दूंगा कि आपको ये ना लगे कि जो भी वैल्यूज आई हैं वो सारी की सारी जीरो हैं। So that's why I'm just showing you with the max size option here.
देखने के लिए एक्सट्रेन जीरो करने से भी हो जाएगा, दिखा देगा।
Sorry,
एक्सट्रेन जीरो करने पे भी दिखा देगा।
extreme zero. Sorry, I didn't get that.
एक्सटेंड ये स्क्वायर ब्रैकेट जीरो
अच्छा,
पहला वाला।
हाँ, you can do that also, but that will be only for value at अच्छा हाँ first index पे ही है generally. Yeah, 2-dimensional है ना, हाँ right. ऐसा भी आप एक्सेस कर सकते हैं, ठीक है, not a problem. Just let me just stop that. Oh my god, I think I've got that. मेरा एक बार रन टाइम रीसेट हो गया, I'll just execute these codes again. ठीक है, so now you can see that अभी आपके पास सिर्फ एक इंडेक्स का वैल्यू है आउट ऑफ इंडेक्स 0। ठीक है, ये फर्स्ट एक स्पेसिफिक का इंफॉर्मेशन है जो आपका क्या कहते हैं ट्रेनिंग के अंदर इंडेक्स नंबर 0 के ऊपर जो डेटा अवेलेबल है। बट अगर आप पूरा का पूरा कंटेंट प्रिंट करना चाहते हैं तो लेट्स जस्ट क्विकली चेक दैट। ओके, दो इट्स टेकिंग अ लॉट ऑफ टाइम। जो ऑब्जेक्टिव था खैर वो अकम्प्लिश हो गया है कि आप वैल्यूज अंदर सारी जीरोज नहीं है और देयर आर डिफरेंट वैल्यूज अवेलेबल। और आप एक बार इस चीज़ को पोस्ट द सेशन यू कैन चेक हाउ numpy is printing the complete information. Okay, so I'll just stop that here and we'll just quickly pursue the next statement here. Let's just quickly run that. Okay, तो मान लीजिए अभी आपके पास यहाँ पे इस तरीके से अब वैल्यूज हैं। एक्सट्रेन पहले आपके पास 0 था, अब हमने उसको फ्लोट 32 के साथ में रिप्रेजेंट कर दिया है एंड वी हैव गॉट सम इंफॉर्मेशन हियर। ओके, दिस इज डी फ्लोट 32. Now what next we need to do? So once you have got this information represented, now we are going to convert for the test data as well. So let's quickly go for the test. Use as type function, define that you would like to convert that into float 32 and divide that with 255. Okay, and you can quickly save that into testing data. So we have converted both the training and testing into the float 32 from the integers. Now what next we need to do? We actually need to reshape it as well, so that reshaping in the in with respect to the number of elements in the training and with respect to the product of the shape of the value out of the one. So that's what we are going to do. Reshape कर लेते हैं इसको डेटा को. ठीक है, reshape करने के लिए आपको क्या करना पड़ेगा? You are going to call extrain.reshape. In order to reshape, what next you're going to do? You have to give the number of rows and the number of columns. The number of rows will be the length of the data in the extrain. तो जितने number of elements आपके पास training data के अंदर हैं, that is going to be your number of rows. Okay. And what you're going to have, the next will be, you're going to take a product. There's a function known as product in which you're going to provide the value, and this is going to be the number of rows जितनी आपकी extraining के अंदर हैं, ठीक है, उसके साथ that we are going to take. So in order to do that, we're going to define that np.product. What it actually does, it returns the product of array elements over a given axis. Okay. So now what we are going to do, we're going to make use of the training data. We're going to simply get the shape of the data, and we are going to read from the index value 1 and up to the end. So now what you're going to get, you're going to get the xtrain in this format. So you have got the data reshaped. तो अब क्या होगा, जो भी आपका ट्रेनिंग डेटा का लेंथ है, जितने नंबर ऑफ एलिमेंट्स हैं उतनी नंबर ऑफ आपके पास रोज बन जाएंगी. ओके. सिमिलरली जब तक ये प्रिंट हो रहा है, you can also quickly reshape the testing data also in the same way. And okay, one thing I do need to do, I just forgot, I need to save that into training also. Okay, so अभी जो भी आउटपुट आएगा वो एक्चुअल आउटपुट नहीं है जो हमें चाहिए था. अब आप इसको दोबारा रन कर सकते हैं, ठीक है, एंड यू कैन चेक बैक. Time is running out, so I'll just be a little quick. You can later print these and you can check back कि क्या outputs आ रहे हैं इनके. Let's just quickly go for the test also. We're going to reshape the test, and again to reshape that, you are going to take the length of the test values, x test, followed by you're going to take the product of your test data, and you're going to take the shape of that data. From that, you're going to slice from item index 1 to end, and you're going to save that into x test. Okay, so once you have got the arrangements done, the reshaping arrangements done, and if you all remember, I have already shared a document with you कि मैट्रिक्स मल्टीप्लिकेशंस करने के लिए शेपिंग रीशेपिंग कैसे करनी होती है. मैं दोबारा आप लोगों को याद दिला रहा हूँ, उस डॉक्यूमेंट को जरूर रेफर कर लीजिए. तो ये जब भी हम रीशेपिंग करते हैं वो आप लोगों को 100% क्लियर हो जाएगा कि क्यों हमें बार बार रीशेपिंग करनी पड़ती है. क्योंकि जो डेटा आपके पास जिस फॉर्मेट पे अवेलेबल है, जब आप उसको न्यूरल नेटवर्क पे रिप्रेजेंट करते हो, तो आपने अभी वीडियो में भी देखा था कि ठीक है, पहले आपके पास कुछ नंबर ऑफ पिक्सल्स रो वाइज एंड कॉलम वाइज है, बट अब आप उन सबका प्रोडक्ट लेके उस सारी की सारी इंफॉर्मेशन को आपको इन अ सिंगल लेयर ऑफ न्यूरॉन्स आपको रिप्रेजेंट करना है. दैट्स व्हाई वी डू नीड टू रीशेप दैम. ओके, so you can understand about matrix multiplications from the document which I have already provided. Okay, so just for a quick information, you can quickly check the shape of the new training data as well as the shape of the new testing data, so that you will get to know how many rows and columns we do have in the data set. Okay, so let's quickly run. So now you can see that in the training data, we have 60,000 samples. Okay, we have 60,000 samples with 784 columns, which means for every character which is available, for every character image which is available in the input, has 784 columns, and each column is representing a value which will give you the input image. Similarly, in the testing data, what we have 10,000 samples in testing data, and it also has 784 columns. Okay, 10,000 rows, 10,000 images in the testing data, and 784 features or columns. Okay, now let's start with the training process. Okay, so we have already created an autoencoder. So what we are going to do, let's use autoencoder. Earlier when we were creating the models in our previous sessions, तो जो भी हम ऑब्जेक्ट बनाते थे उसके थ्रू हम कॉल करते थे ट्रेन फंक्शन, बट यहाँ पे जो ट्रेनिंग फंक्शन है उसका नाम है फिट. So this fit actually trains the model for the fixed number of iterations on a data set, for the fixed number of epochs. Okay, so first you have to provide the value of x. Let's just provide x train. Okay, second value you have to provide is y, which is going to be your अच्छा, यहाँ पर तो हमें दोनों ही x और y में ट्रेनिंग डेटा ही देना पड़ेगा. Okay, then because we don't have a y value here, so hence we have given the x training in both x and y, followed by a number of epochs you have to define. So let's say we'll be training that for 50 number of iterations. I've just selected it randomly. We'll see what is the result. In case if we are not reaching to nearby loss of 0, then we will increase the epochs. Okay, followed by this offers batch processing also. So your data can be divided into batches and can be processed at the same time. So that will actually help you save a lot of time while training. So this is a nice option which we didn't have in the previous examples which we have taken. The batch size will actually perform processing batch wise. Then there is another value, batch size we have taken. Then shuffle is already true, we don't need any of that. For validation, we do have the validation data set also here, which is set to none. Validation data is set to none. So we are going to define the validation data that is going to be our test set in order to quickly check whether our model is fine or not. So validation data, we are going to validate the training with the testing data which we have got. X test, we are going to provide both. Generally यहाँ पे जो ऑटो एनकोडर है इसमें x और y वैल्यूज होती है, बट सिंस y इज अननोन टू अस, इसलिए हम दोनों ही फीचर्स में हम टेस्टिंग की x वैल्यूज ही पास कर रहे हैं. ओके, now what we are going to do, we are going to train the model. Let's just quickly run fit function and let's just train the model. So you must compile a model before ट्रेनिंग और टेस्टिंग. अच्छा, यूज मॉडल डॉट कंपाइल. एक हमें ऑप्टिमाइजर और एक लॉस फंक्शन भी डिफाइन करना पड़ेगा. ठीक है, सो जस्ट टू डू दैट, बिफोर दिस स्टेटमेंट जस्ट इंट्रोड्यूस वन मोर लाइन ऑफ कोड वेयर यू हैव टू कंपाइल द मॉडल. यहाँ पे एक और चीज है कि पहले आपको मॉडल को एक स्पेसिफिक ऑप्टिमाइजेशन एल्गोरिथम और लॉस एल्गोरिथम के साथ में कंपाइल करना पड़ता है, सो दैट हमारा जो भी कोड रन करे वो ऑप्टिमाइज्ड हो, जो भी लॉस हो वो मिनिमाइज्ड हो. ओके, सो जनरली ऑप्टिमाइजेशन के लिए वी डू हैव द एल्गोरिथम नोन एज एडा डेल्टा व्हिच वी यूज. यू कैन एक्सप्लोर अबाउट एडा डेल्टा ऑन ऑप्टिमाइजेशंस ऑन गूगल. आप विकिपीडिया पे भी चेक कर सकते हैं, आपको उसकी इक्वेशंस मिल जाएंगी. मोरओवर वी डू हैव बाइनरी क्रॉस एंट्रोपी फॉर लॉस कैलकुलेशन. सो लेट्स जस्ट क्विकली डिफाइन दैट. ऑटो एनकोडर dot compile, there is an option known as compile, which actually takes what this compile will do. It configures the model for training. So you do need to have an optimizer and you do need to have the loss function, the loss algorithm. Okay, और भी यहाँ पे कुछ कई सारे options हैं, so आप एक बार explore कर सकते हैं from the documentation of Keras. So let's just quickly take the optimizer. So optimizer I would like to take as ADA delta. यही आप use कर लीजिए. Common एल्गोरिथम्स में आप यूज कर सकते हैं। और लॉस के लिए हमारे पास है बाइनरी क्रॉस एंट्रोपी। ओके, आगे मैं आप लोगों के साथ ये डिस्कस करूंगा इन अपकमिंग सेशंस की क्या होते हैं ये। आज अपने पास समय थोड़ा कम है, इसलिए आई डोंट वांट टू डीप डाइव इनटू ऑप्टिमाइजर्स और लॉस फंक्शंस क्या हैं। ओके, Auto-encoder.compile optimizer add a delta and the loss which we have taken is binary cross entropy. ओके, अब रन कर दीजिए इसको। अब जब आप इसे रन करेंगे तो आप देखिए आपका ट्रेनिंग स्टार्ट हो गया। ओके, सो ऑन फर्स्ट आइटरेशन, सेकंड आइटरेशन, थर्ड आइटरेशन अब हमारा लॉस मिनिमाइज होगा। So we are training on 60,000 samples and we are validating on 10,000 samples. और वैलिडेशन हम क्यों कर रहे हैं, आपको याद होगा हम जब भी वेट्स एडजस्ट करते हैं तो हम क्या करते हैं, हम आउटपुट कैलकुलेट करते हैं, ठीक है, और आउटपुट को एक्टिवेशन से कैलकुलेट करते हैं। यानी हम एग्जिस्टिंग आउटपुट लेते हैं और एक्टिवेशन से आउटपुट कैलकुलेट करते हैं। दोनों को जब हम माइनस करते हैं तो हमें एरर मिलता है, ठीक है। उस एरर के बेसिस पे हम वेट एडजस्ट करते हैं। सिमिलरली हियर यहाँ पे कैसे वैलिडेट हो रहा है, उन 10,000 सैंपल्स के बेसिस के ऊपर वैलिडेट हो रहा है। ओके, नाउ वंस द वैलिडेशंस विल बी डन, इसके बाद में हम क्या करेंगे, हमें बस अपनी इमेजेस को विजुअलाइज करना है।
सर वैलिडेशन और प्रेडिक्शन में क्या डिफरेंस है?
प्रेडिक्शंस आप इनपुट के ऊपर करते हैं, वैलिडेट आप जब करते हैं तो आप उस डेटा के ऊपर टेस्ट करते हैं जो ट्रेनिंग में आपके पास अवेलेबल नहीं था। तो अगर उस डेटा के ऊपर भी आपका एरर मिनिमाइज जा रहा है, दैट मीन्स कि आपका जो मॉडल है वो एक वैलिड मॉडल है।
ओके, दैट मींस कि हमारे डेटा के अलावा कोई और डेटा से अगर हम टेस्ट करें, दैट इज कॉल्ड वैलिडेशन। लाइक
नहीं, आपके डेटा सेट के अलावा कोई और डेटा सेट नहीं, आपके डेटा सेट में से ही कुछ नंबर ऑफ ऑब्जर्वेशंस आप ट्रेनिंग के लिए यूज करेंगे और बाकी जो बचे ऑब्जर्वेशंस हैं वो आप टेस्टिंग के लिए यूज करेंगे। बिकॉज
वो तो टेस्ट, वो तो ट्रेन, हाँ सर, लेकिन आपने
होता है ऑटो एनकोडर इज डेटा स्पेसिफिक एंड यू कैन नॉट यूज ऑटो एनकोडर कि आपने ट्रेनिंग कर दिया कैट्स के डेटा सेट से और आप प्रिडिक्ट कर लें ह्यूमंस को, वो नहीं हो सकता है ऑटो एनकोडर में।
वैलिडेशन के लिए फिर हमें कहीं अलग से डेटा लेना पड़ रहा है क्या? मतलब जैसे मैंने 1000 इमेजेस से
I cannot hear because you are speaking either very slow or there is some issue with the mic. So could you please speak a little loud so that I can hear?
Okay sir, am I audible sir now?
Yeah, you are audible now.
Okay sir, मेरा कहने का मतलब ये है कि let we have 1000 images और उन 1000 इमेजेस में से हमने अपने डेटा को 80% यूज फॉर ट्रेनिंग, 20% यूज फॉर टेस्टिंग। अब वैलिडेशन इसमें अब कैसे होगा, आप ये बताइए, ये नहीं समझ।
वैलिडेशन ऐसे होगा कि आपने जब ट्रेनिंग के लिए आपके पास टोटल 70,000 सैंपल्स थे। आई थिंक आप मशीन लर्निंग में नए हैं, बेसिक्स आपने पढ़े नहीं है मुझे लगता है, लेकिन मैं आपको बता देता हूँ। होता क्या है कि जब आप इमेजेस लेते हैं, 70,000 आपने इमेजेस लिए हैं, जब आप ट्रेनिंग करेंगे तो ये 70,000 जो डेटा है उसमें 70,000 कैरेक्टर्स नहीं है, एक स्पेसिफिक कैरेक्टर के मल्टीपल इम्प्लीमेंटेशंस हैं। जैसे मान लीजिए अगर मैं यहाँ पे ड्रॉ करूँ एक 7 कैरेक्टर, ठीक है, मैं रैंडमली ऐसे ड्रॉ कर रहा हूँ ताकि एक तो 7 अच्छा हो सकता है, ठीक है, एक किसी ने 7 इस तरीके से बनाया हो सकता है, एक ऐसे 7 हो सकता है, ठीक है, एक 7 किसी ने ऐसे बनाया हो सकता है, एक 7 ये हो सकता है। तो इन अ डेटा देयर विल बी मल्टीपल इनपुट्स अवेलेबल। अब मान लीजिए एक कैरेक्टर के 2 इंफॉर्मेशन आपके पास आ गई हैं ट्रेनिंग के अंदर, ठीक है, बाकी मान लीजिए ये जो 2 हैं ये आपके पास आ गई हैं टेस्टिंग के अंदर, ठीक है, कंसीडर दिस एज अंडर ट्रेनिंग। तो जब हमने डिवाइड किया है, ये वो 60,000 सैंपल्स हैं एंड दीज आर योर 10,000 सैंपल्स। ओके, तो अब आपने 60,000 कैरेक्टर्स से अपने मॉडल को ट्रेन कर दिया जो सेम कैरेक्टर्स को रिप्रेजेंट करते हैं 0 से 9 के बीच में। अब रैंडमली टेस्ट करने के लिए जब आप प्रेडिक्शन करेंगे तो इन्हीं वैल्यूज को नहीं यूज करेंगे आप प्रेडिक्शन करने के लिए, अदरवाइज ये हो सकता है कि मॉडल ने उसको रिमेंबर कर लिया हो, ठीक है। तो इसलिए हम डिवाइड करते हैं अपने डेटा सेट को और जो दूसरे कैरेक्टर्स हैं उसके ऊपर हम प्रेडिक्शन परफॉर्म करते हैं, ठीक है। अब प्रेडिक्ट फंक्शन इज गोइंग टू बी कॉल्ड ओवर दिस डेटा, और जब हम यहाँ प्रिडिक्ट करने पे एक 7 देंगे और अगर आउटपुट में वो हमें रिटर्न करता है कि हाँ ठीक है, जो आपने आउटपुट प्रिडिक्ट किया वो 7 है, सो दैट मीन्स एरर 0 है। ओके, यहीं पे अगर वो कहता है कि नहीं 7 नहीं आया, आउटपुट 8 आया है, तो वी आर गोइंग टू एक्सपीरियंस सम एरर, लेट्स से 0.98 समथिंग समथिंग, वी हैव गॉट एन एरर समवॉट लाइक दैट। ओके, सो दिस इज हाउ वी वैलिडेट कि 0 से जितना क्लोज वैल्यू होगा हमारा मॉडल उतना बेहतर होगा। इज दैट क्लियर नाउ?
ओके सर।
ओके, प्लीज एक बार अपने बेसिक्स रिवाइज कीजिए,
सर
क्योंकि
एक्चुअली में मैंने लेट ज्वाइन किया है न्यूरल नेटवर्क से, इस वजह से मैंने
न्यूरल
प्रीवियस क्लास
नेटवर्क हो या कोई भी सुपरवाइज का एक सिंपल सा हाउस प्राइस प्रेडिक्शन का डेटा सेट हो या एक कोई भी आइसक्रीम का डेटा सेट हो, कॉन्सेप्ट मशीन लर्निंग के सेम है। ओके, देयर इज नो डिफरेंस एट ऑल इन एनी ऑफ द कॉन्सेप्ट्स। पीपल आई डोंट नो व्हाई पीपल आर सो मच स्कैर्ड ऑफ आर्टिफिशियल न्यूरल नेटवर्क्स एंड डीप लर्निंग, जबकि कॉन्सेप्ट कुछ है ही नहीं अलग। The same concept from the day one which you start learning on machine learning is repeated up till the end of machine learning. Okay? कोई भी differences नहीं है उसमें implementation approach में। पहले भी जब हम start करते थे तो हम knowledge discovery process SEMA model ही use करते थे, वही काम हम आज भी कर रहे हैं। ठीक है, अगर आपको मैं याद दिलाऊं, अगर आपने previous sessions attend किए हैं तो we used to have SEMA which is
सर एक्चुअली मैंने जब से आपने सेशन लेना स्टार्ट किया तब से स्टार्ट किया, मैंने स्टार्टिंग की सेशन नहीं की।
That's fine, but अगर आपने एडवांस कोर्स ज्वाइन किया है तो बेसिक्स तो आपने पढ़े होंगे ना।
हाँ सर, पहले पढ़े हुए हैं।
बेसिक्स तो आपने पढ़े होंगे ना, तो या तो आपने बेसिक्स ठीक से नहीं पढ़े हैं या आपको रिवाइज करने की जरूरत है। दैट्स ऑल आई एम सेइंग।
यस
लेट मी जस्ट टर्न ऑन द कैमरा, अदरवाइज आप घबरा जाएंगे कि मैं कहीं आपको डांट तो नहीं रहा हूं।
नो सर।
So I am laughing and I am saying that
ओके
the 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 mod the framework which we used to have in supervised, it is similar in unsupervised. There is nothing uh, which is different from the basics which we have learned. Okay, तो जब हम मॉडिफिकेशन करते हैं, वैलिडेशंस करते हैं, असेसमेंट करते हैं, तो असेसमेंट में पहले भी हम ऐसे ही करते थे कि हम वैलिडेशन डेटा सेट लेते हैं या ट्रेनिंग टेस्टिंग में स्प्लिट करते हैं, उसके बाद में टेस्ट करते थे। स्प्लिट करने का मतलब ये नहीं है कि वहाँ पे कैरेक्टर्स कुछ और होंगे, बट इट इज जस्ट अ रैंडम डिस्ट्रीब्यूशन ऑफ द डेटा अवेलेबल। ओके, जो आपके पास टेस्ट सेट हैं उससे रिलेवेंट सिमिलर कैरेक्टर्स आपके पास ट्रेनिंग में होंगे, तभी वो एक्चुअली उसे प्रेडिक्ट कर पाएगा, नहीं तो नहीं कर सकता। और इसलिए मैंने ये कुछ पॉइंट्स बाय डिफॉल्ट यहाँ पे रखे हैं ताकि किसी को कहीं पे भी कंफ्यूजन ना आए कि ऑटो एनकोडिंग इज सिमिलर लाइक अ डेटा स्पेसिफिक होती है ऑटो एनकोडिंग। ओके, इज दैट क्लियर?
ओके सर।
आई होप दिस इज क्लियर।
ओके सर।
बट आपको क्लियर हो गया है ना? दैट्स मोर इम्पोर्टेंट।
प्लीज।
ओके, चलिए अब मैं कैमरा मोड से हटता हूँ एंड लेट मी जस्ट क्विकली एक्सप्लेन अगेन। सो आई थिंक दिस कॉन्सेप्ट इज क्लियर टू एवरीवन कि आप सैम्पलिंग और कैसे करते हैं, मतलब वैलिडेशंस हम किस तरीके से कर रहे हैं। ठीक है, कैरेक्टर्स का डेटा है तो कैरेक्टर्स ही स्कैन हो सकते हैं या प्रेडिक्ट हो सकते हैं। कैरेक्टर्स के बेसिस पे until and unless you will learn the concepts of transfer learning, उससे पहले मैं आपको यही कहूँगा कि आपका जो भी ये न्यूरल नेटवर्क ऑटो एनकोडिंग है वो डेटा स्पेसिफिक है। बट जैसे जैसे आप आगे बढ़ेंगे तब आप समझेंगे कि आप एक टाइप ऑफ डेटा को ट्रेन करके दूसरे टाइप ऑफ डेटा को प्रेडिक्ट कर सकते हैं। ठीक है, यानी आप कार से डेटा को ट्रेन कर लीजिए, लेकिन आप ट्रेन, बस, एरोप्लेन, कुछ और दूसरी चीज़ों को भी प्रेडिक्ट कर सकते हैं। दैट इज द कॉन्सेप्ट ऑफ ट्रांसफर लर्निंग। वो अभी आप लोग आगे सीखेंगे। ठीक है, वो है आपके करिकुलम में ट्रांसफर लर्निंग, which I believe will come approximately at the end of these AI sessions, artificial neural network sessions। यहाँ पे है मेरे ख्याल से CNN RNN पढ़ेंगे आप, फिर उसके बाद में आप ट्रांसफर लर्निंग पे जाएंगे। ठीक है, कि आप कैसे एक टाइप के डेटा से लर्न कर सकते हैं और दूसरे टाइप के डेटा को प्रेडिक्ट कर सकते हैं। चलिए, एनीवेज, सो नाउ वी हैव डन दिस फिटिंग। एवरीबडी इज क्लियर विद द कॉन्सेप्ट टिल हियर? यहाँ तक सभी क्लियर है? अब आपको करना क्या है, अब आपको एनकोडेड और डिकोडेड इमेजेस को प्रेडिक्ट करना है। ठीक है, वैलिडेशंस में तो ऑलरेडी प्रेडिक्शन हो चुका है, बट मैं आपको प्लॉट बना के दिखाऊंगा कि एक्चुअली कैरेक्टर्स कैसे दिख रहे हैं। ठीक है, हमारा वैसे मशीन लर्निंग ऑटो एनकोडिंग का काम हो गया, वैलिडेशन आ गई, हमें लॉस दिखा रहा है कि ठीक है भाई मिनिमम लॉस है। ठीक है, कोई ऐसा बहुत बड़ा लॉस नहीं आ रहा, तो मिनिमम लॉस, ठीक है। तो अब करना क्या होगा, अब आप देखिए। सो अब हम प्रिडिक्ट करते हैं पहले, क्योंकि इन प्रिडिक्शंस को यूज करके हम इमेजेस को ड्रॉ करेंगे। सो मैंने एक प्रिडिक्ट फंक्शन लिया कि एनकोडर के साथ मैं प्रिडिक्ट करना चाहता हूँ अपने टेस्ट सेट को, एंड आई एम गोइंग टू सेव दैट इनटू encoded images. Okay, I'm going to save that into encoded images. Let's keep it short, imgs images. Similarly, we are going to decode decoder dot predict. ठीक है, अब आप ट्रेन कर चुके हैं, मॉडल आपका ट्रेन हो चुका है। तो पहले आपने क्या किया, टेस्टिंग डेटा ले रहे हो आप, जो आपके पास सैंपल है 10,000 का, वो अभी आप ले रहे हो। उसको लेने के बाद आप एनकोडेड इमेजेस में उसे सेव कर रहे हो, ठीक है। अब इस एनकोडेड इमेजेस के थ्रू आप डिकोड करोगे इसको। तो आप encoded images ले लीजिए, we're going to take encoded underscore images, and now you're going to save that into decoded images. Okay, now let's see. So we got encoded images as well as the decoded images. ये मैंने क्यों निकाली हैं, I think मैंने ऊपर encoded बनाया था ना, encoded and decoded. Just hold on for a minute. I've got the autoencoder, and where I have defined the encoders and decoders, xtrain, xtest. I've got the xtest, encoded, decoded. अच्छा, ये तो मेरे सिर्फ ओके, ठीक है। अच्छा, एक काम और करना पड़ेगा। तो व्हाट वी हैव टू डू इज, यहाँ पे हमें ना कुछ पहले हमें ना स्पेसिफिक स्लाइसिंग करके एनकोडर्स और डिकोडर्स भी हमें यहाँ पे निकालने पड़ेंगे। सो व्हाट वी विल डू इज, एक काम करते हैं कि ये वाला जो पार्ट है यहाँ से विल कंटिन्यू टुमारो, बिकॉज आई हैव अ कंटिन्यूअस सेशन अगेन शेड्यूल, जो मेरा एक दूसरा सेशन है अगला। सो व्हाट वी विल डू, कल के हम सेशन में यहाँ से आगे कंटिन्यू करेंगे। जब आप ट्रेनिंग कर चुके हैं तो आउट ऑफ दिस एनकोडेड इमेजेस एंड डिकोडेड इमेजेस, अब हमें जनरेट क्या करना होगा, हम कुछ एनकोडर्स और डिकोडर्स जनरेट करेंगे, और उस बेसिस के ऊपर फिर हम अपने इमेजेस को एक्सट्रैक्ट करके डिस्प्ले करेंगे, ठीक है, ताकि हम प्रेडिक्शन परफॉर्म कर पाए। ओके, सो दैट वी विल कंटिन्यू फ्रॉम टुमारो फ्रॉम हियर। सो टिल नाउ आई होप इट इज क्लियर टू एवरीवन कि अभी आपने क्या किया है, आपने अपना मॉडल जनरेट कर लिया है, ऑटो एनकोडर मॉडल विथ ट्रेनिंग data on 50 number of iterations, and there is one more step in between which we need to work out on. We have to create a custom encoder and decoder with which we are going to perform the predictions, and once we are going to do that, फिर उसके बाद में हम images को generate करके यहाँ पे देखेंगे कि जब आपने high quality से low quality में generate किया है तो क्या differences आते हैं। Is that clear? So tomorrow onwards we will continue from here. So by the time what I can do is, let me just take an image of this so that we can use it tomorrow. So till now, have you all got the output till here? Auto encoder आपका बन चुका है, और बेसिक आप लोगों को क्लियर हो गए हैं कि डेटा स्पेसिफिक होता है ऑटो एनकोडर, लॉसी होता है, and again we learn through the weights here, and the prediction part and generation of the image part will continue tomorrow. Any questions, anyone in today's topic till now? अगर किसी जगह कोई भी कंफ्यूजन है तो आप मुझसे पूछिए, या फिर आप डॉक्यूमेंट्स को, जो मैंने आपको डॉक्यूमेंट शेयर किए, इनको रेफर कीजिए। मॉडल्स, एक्टिवेशंस, विजुअलाइजिंग द न्यूरल नेटवर्क। ओके,
हेलो सर,
ये हम ये सारी बातें कर चुके हैं। इनफैक्ट आगे हम CNN वगैरह भी पढ़ेंगे। CNN में आप इस तरीके से फीचर मैप्स बनाएंगे और फिर आप आइडेंटिफाई करेंगे, या आगे आप अभी बनाओगे। न्यूरल नेटवर्क्स के कॉन्सेप्ट आप लोगों को क्लियर हैं, वो हम पढ़ चुके हैं। बेसिक ऑटो एनकोडर होता क्या है ये भी आपको क्लियर है कि पहले आप एनकोड करोगे, आप डिकोड करोगे। और सबसे बड़ी बात जो ये है कि आप लोगों को अब ये क्लियर है कि किसी भी स्पेसिफिक फ्रेमवर्क को, यानी केरास को यूज करके आप किस तरीके से अपने लेयर्स को क्रिएट कर सकते हैं। दैट्स व्हाट इज इम्पोर्टेंट। जो अब तक आप अभी अपने कस्टम फंक्शंस पे डिजाइन कर रहे थे, वन लेयर विद सम बेसिक इनपुट्स, अब आप बड़े बड़े नंबर के न्यूरॉन्स को एक एक लेयर में डिफाइन करके आप आगे उसे प्रोसेस कर सकते हो। ओके, So guys, if anybody, any questions, just let me know. Or else we are done for today's session. We'll continue from tomorrow for the prediction part.
Hello, sir. Hello.
Okay.
हेलो सर।
Yes.
सर मैं बोल रहा हूँ वो तो मशीन लर्निंग में ट्रेस टेन स्प्लिट को तो वो तो है, तो उसमें तो जानता हूँ, बट ये वैलिडेशन जो है, वैलिडेशन के डेटा के अंदर जो दो पैरामीटर हम लोग पास कर रहे हैं टैपल में, एक्सटेंड एक्सटेंड क्यू, यही मैं बोल रहा हूँ, एक्सटेस्ट कॉमा एक्सटेस्ट।
आपकी आवाज क्लियर नहीं आ रही, दोबारा पूछिए। वैलिडेशन के डेटा में
वैलिडेशन के लिए इक्वल्स टू के लिए एक्सटेस्ट कॉमा एक्सटेस्ट क्यू दे रहा है हम लोग, यानी दो सेम क्यू दे रहा है।
वैलिडेशन के स्टेप में एक क्या दे रहे हैं?
एक्सटेस्ट कॉमा एक्सटेस्ट, यही मैं बोल रहा हूँ।
Could you please write on the text so that at least I should be able to read
I mean
that?
fifth line validations data equals to extest.
Fifth line on what cell, my
14
friend? Sorry?
14 में fifth line जो है,
हाँ ये
एक्सटेस्ट क्यों दे रहा है?
हाँ यहाँ पे क्या है, मतलब what do you want to ask? I cannot get the question clear.
I mean क्यों दे रहा है एक्सटेस्ट कॉमा एक्सटेस्ट, यही मैं बोल रहा हूँ।
Could you please, I really request you, मैं हाथ जोड़ के आपसे रिक्वेस्ट कर रहा हूँ कि अगर आप मुझे टेक्स्ट में लिख देंगे ना तो मैं एटलीस्ट सुन पाऊंगा या पढ़ पाऊंगा। ठीक है, आप मुझे टेक्स्ट में लिख दिए, एटलीस्ट मैं पढ़ तो सकता हूँ कि आप क्या क्वेश्चन पूछ रहे हैं।